Hey champs of Examsnet, welcome to the question series of Examsnet. I hope this series of detailed explanation is helping you a lot. So in today's session we are going to discuss NEET 2014 physics paper and we have 45 questions here. So let's start the session. The first question is from the chapter Units and Dimension, and the question is, if force, velocity and time are taken as fundamental units, then the dimensions of mass are. Okay. So we know that force is equal to mass into acceleration, and acceleration is the rate of change of velocity, right? A equals to V upon T. So force equals to mass into velocity upon time. Okay. Now we have to find the dimension of mass. So mass will be equal to F into T upon V. So this can be written as F into V minus 1 into T. So this will be the dimension of mass, because here force, velocity and time, all three are the fundamental units. Okay. So the correct answer will be option number D, F V minus 1 into T. Question number 2 is from the chapter Motion in a Plane, and the question is, a projectile is fired from the surface of the earth with a velocity of 5 meter per second and angle theta with the horizontal. Another projectile fired from another planet with a velocity of 3 meter per second at the same angle follows a trajectory which is identical with the trajectory of the projectile fired from the earth. The value of acceleration due to gravity on the planet is. Okay, so here we have two cases. In the first case, the projectile has been fired from the surface of the earth. Okay, so what is the value of acceleration due to gravity on the earth? That means G1 is 9.8 meter per second square. It is already mentioned in the question. Okay, the value is given. And the velocity at which the projectile has been fired, that means V1, is 5 meter per second. Now in the second case, the projectile has been fired from another planet, right? So let's say that the acceleration due to gravity of that planet is G2 and we don't know the value of G2. Okay, but the velocity at which the projectile has been fired is 3 meter per second. So V2 is equal to 3 meter per second. Okay, now there is a trajectory equation. According to this equation, y is equal to x tan theta minus gx square upon 2u square cos square theta. Okay, so it is given in the question that in both the cases the trajectory is same. Okay, angle is same angle, and the trajectory is also same. Okay, identical trajectory. So for equal trajectory, the value of y should be same. That means for y should be same, g upon u square should be constant, or it should be same. So it means that g1 upon u1 square should be equal to g2 upon u2 square. Okay, now let's put the values. G1 is 9.8 meter per second square. So 9.8 upon u1 is 5 meter per second. So u square will be 25. Okay. Similarly, this side we have G2, we don't know the value of G2, and U2 is 3 meter per second, so U2 square will be 9. Okay, so from here we can find the value of G2. So G2 will come out to be 3.528 meter per second square. Okay, if you solve this. So this will be the acceleration due to gravity on the other planet from where the projectile had been fired. Okay, so the approximate value is option number A, 3.5. So this will be the correct answer. Question number 3 is again from the chapter Motion in a Plane, and the question is, a particle is moving such that its position coordinates x and y are 2 meter, 3 meter at time t equals to 0, 6 meter, 7 meter at time t equals to 2 seconds, and 13 meter, 14 meter at time t equals to 5 seconds. Average velocity vector V average from t equals to 0 to t equals to 5 second is. Okay, that means we have to consider these two. Okay, this is the first one and this is the second one. That means t equals to 0 and t equals to 5 seconds. Only these two can be considered to solve this question. Okay, so from the first one, it is clear that the value of x is 2 meter and the value of y is 3 meter. So let's say that the x1 is 2 and y1 is 3. Similarly, from the second one, x is equal to 13 meter and y is equal to 14 meter. So x2 is equal to 13 and y2 is equal to 14. Okay. Now we have to find out the average velocity vector. So that will be equal to x2 minus x1 I cap plus y2 minus y1 j cap upon t2 minus t1, right? This is how we find the average. So let's put the values here. x2 is 13 minus x1 is 2 I cap plus y2 is 14 minus y1 is 3 j cap upon t2 is 5 seconds and t1 is 0 seconds, right? So on solving this we get 13 minus 2 I cap, that means 11 I cap plus 14 minus 3 I cap j cap, that means again 11 j cap upon 5 minus 0 seconds, that means 5. Okay, so it can be written as 11 upon 5 I cap plus j cap. Okay, so the correct answer will be option number D. Question number 4 is from the chapter Laws of Motion, and the question is: a system consists of three masses m1, m2 and m3 connected by a string passing over a pulley P. The mass m1 hangs freely and m2 and m3 are on a rough horizontal table. The coefficient of friction is F. The pulley is frictionless and of negligible mass. The downward acceleration of mass m1 is. Assume m1 equals to m2 equals to m3 equals to m. Okay. So we have to assume that all the masses are equal. That means this is m, and this is also m. We have to find the downward acceleration of this mass m1. Okay. Now, what will be the frictional force on this m3? It will be mu mg, and the frictional force on m2 will also be mu mg. Okay. So the total frictional force will be 2 mg. Okay. 2 mu mg. This will be the total frictional force on masses m2 and m3. Now we have to find the acceleration, downward acceleration. So that will be equal to resultant force. That means the force along the acceleration minus the force opposite to the acceleration. That means the frictional force. Okay, upon total mass. So force along the acceleration, that means this downward motion, it will be equal to mg minus the force opposite to the motion, that means the frictional force. We have seen that the total frictional force is 2 mu mg. Okay, so minus 2 mu mg upon the total masses. So there are three equal masses, so it will be 3m, right? Now from here we can take mg common. So what will be left? 1 minus 2 mu upon 3m. So m will be cancelled, and what is left here? G 1 minus 2 mu upon 3. Okay, so let's have a look at the options. G 1 minus 2 mu upon 3, it is mentioned in option number C. So option C will be the correct answer. Question number 5 is again from the chapter Laws of Motion, and the question is: the force F acting on a particle of mass m is indicated by the force time graph shown below. The change in momentum of the particle over the time interval from 0 to 8 seconds is. Okay, so we have to find the change in momentum, that means delta P, and that will be equal to force into change in time. Okay, F dot delta T. So from this Ft graph, force versus time graph, what will be the product of force and time? It will be the total area under the graph. Okay, so it will be the area under the Ft graph, right? Now what will be the total area under the graph? First you can see there is a triangle. Okay, so what will be the area of this triangle? Since this is a right angle triangle, so it will be half into base into height. Okay, and this is for any triangle. This formula is for all the type of triangle, half into base into height, but this is a right angle triangle, so this side is the height. Okay, so half into, what is the base? It is from 0 to 2. Okay, along the x-axis, so it will be 2, and height is from 0 to 6 along the y-axis, so it will be 6. So on solving this we'll get 6. Okay, this is the area of the triangle. Now next is a smaller rectangle, okay, this shaded area. So the area of the smaller rectangle will be equal to side along the x-axis into side along the y-axis. So along the x-axis it is from 2 to 4, so the total length will be 2, and along the y-axis it is 0 to minus 3, okay, so it will be minus 3. So the total area will be minus 6. Okay, this is the area of the smaller rectangle. Similarly, there is a bigger rectangle, this one. So the area of the bigger rectangle will be equal to length into breadth. So length is what? 4 to 8 along the x-axis. So this side will be 4. Okay, 8 minus 4, that is 4. And along the y-axis it will be 0 to 3. Okay, 0 to 3, that means 3. So 4 into 3, that will be equal to 12. So this is the area of the bigger rectangle. So what will be the total area under the graph? It will be the area of the triangle, that is 6, plus area of the smaller rectangle, that means minus 6, plus area of the bigger rectangle, that is 12. So 6 and minus 6 will be cancelled, and what will be left? 12. And the unit will be Newton second, because force into time. So the unit of force will be Newton and that of time will be second. So this will be the answer. Okay, 12 Newton second. That means option C will be the correct answer. Question number 6 is also from the chapter Laws of Motion, and the question is, a balloon with mass m is descending down with an acceleration a where a is less than g. How much mass should be removed from it so that it starts moving up with an acceleration a? Okay, so we have a balloon with mass m. It is moving down with an acceleration a. Now what will be the downward force on this balloon? It will be mg, and the upward force, let's say it is F. So the equation for this motion will be the resultant force, that is mg minus F, will be equal to mass into acceleration. So let's say this is equation number 1. Okay. Now in the second case, some mass has been removed from this balloon. Let's say that m dash mass has been removed from it. So what will be the resulting mass? It will be m minus m dash. Okay. So the downward force will be m minus m dash g. Upward force will remain same, that is F, and this time it will start moving up with an acceleration a. So since it is moving up, so F will be greater. So for the equation for this will be F minus m dash g. That means upward force minus downward force will be equal to mass into acceleration. That means m minus m dash into a. Okay, this is equation number 2. We have to find the mass that has been removed, that means m dash. Okay, so let's add these two equations. On adding these two equations, this f and this minus f will be cancelled. So what is left? From the equation 1, mg on the left hand side, and from equation 2, on the left hand side we have minus mg plus m dash g on opening the bracket. Okay, on the right hand side we have mass into acceleration from equation 1, and from equation 2 we have mass into acceleration minus m dash into acceleration. Okay, so this plus mg and minus mg cancel. So on the left hand side m dash g, and let's bring this m dash a this side. Okay, so it will be plus m dash a, and this side ma plus ma, that means 2ma. So let's take m dash common. So g plus a, and we have 2ma. So what is the value of m dash? It is equal to 2ma upon g plus a. Okay, this is the value of mass that has been removed from the balloon. So 2ma upon g plus a, that means option A will be the correct answer. Question number 7 is from the chapter Work, Energy and Power, and the question is, a body of mass 4m is lying in xy plane at rest. It suddenly explodes into 3 pieces. 2 pieces each of mass m move perpendicular to each other with equal speeds u. The total kinetic energy generated due to explosion is. Okay, so we have a body of mass 4m. It explodes into 3 pieces. Okay, so the 2 pieces are of same mass, that is m, and the third piece will have the mass 4m minus 2m, that is 2m. Okay, now the first 2 pieces have equal speeds u, and we don't know what is the speed of the third piece, so let's say it is v. Okay, now it is also given that the first 2 pieces each of the same mass m are moving perpendicular to each other. So if one of them is moving along the x-axis, then the other must be moving along the y-axis. Okay. So what will be the momentum of the first piece that is moving along the x-axis? It will be mu I cap. Similarly, the momentum of the second piece that is moving along the y-axis will be mu j cap. Okay. Now, we know that the total momentum will be conserved. That means the momentum before collision, before explosion will be equal to the total momentum after explosion. Okay. So before the explosion, the body was at rest, so the total momentum was 0. After the explosion, the total momentum will be the momentum of the first body, that is mu I cap, plus momentum of the second body, that is mu j cap, plus momentum of the third body, that is 2mv. Okay. Now we have to find out the v first. So 2mv will be equal to minus mu I cap minus mu j cap. Right. Now 2mv equals to, let's take mu common. So what will be left this side? Minus I cap minus j cap. Right. So m cancelled. And if we find the magnitude of minus I cap minus j cap, it will be 1 square minus 1 square plus minus 1 square under root. Okay, this is how we find the magnitude. That will be equal to root 2. So if it is I cap plus j cap or I cap minus j cap or minus I cap minus j cap, anything, the magnitude will be root 2. Okay, because ultimately we have to square. Okay, we have to find the square. So minus will become plus. So root 2. So in place of minus I cap minus j cap, we can put root 2. Okay, so 2v equals to root 2u. So what will be the value of v? That means the speed with which the third body is moving will be root 2u upon 2. That means u upon root 2. Okay. So this is the speed of the third body. Okay. Speed of the first two bodies were u and the speed of the third body is u by root 2. Now we have to find out the total kinetic energy. Right. The total kinetic energy generated will be equal to kinetic energy of the first body, that is half mu square, plus kinetic energy of the second body, that is half mu square again, because both have same mass and same speed, and kinetic energy of the third body, that means half into 2m into speed is u by root 2, right? So u by root 2 square, that means u square by 2. Okay, square of u by root 2 is u square by 2. So this 2 will be cancelled. If we take half mu square common, so what will be left? 1 from here, 1 from here, and from here also 1. Okay, so 1 plus 1 plus 1, that means 3. So 3 by 2 mu square. Okay, this will be the total kinetic energy generated. Okay, because initial kinetic energy was 0 because the body was at rest. So the final kinetic energy minus initial will be 3 by 2 mu square only. Okay, so let's see which is the correct answer. Option number B will be the correct answer. Question number 8 is from the chapter Simple Harmonic Motion, and the question is, the oscillation of a body on a smooth horizontal surface is represented by the equation x equals to a cos omega t, where x is the displacement at time t and omega is the frequency of oscillation. Which one of the following graph shows correctly the variation of a with t? Okay, so here the equation for displacement is given. Okay, x equals to a cos omega t, but we have to find the correct graph which shows the variation of a, that means acceleration with t. So if displacement is x, what will be the velocity? It will be dx by dt, the differentiation of the displacement. So that will be equal to minus a omega sine omega t. Okay, and acceleration will be equal to the differentiation of velocity dv by dt. So that will be equal to minus a omega square cos omega t. So we have to find the graph for this. Okay, now we know that the graph for cos theta looks like this. Okay, but here we have minus cos theta. Okay, minus cos omega t. So the graph will start from the negative side. That means from here, like this. It will go like this, okay? So according to this, the correct graph will be the third one, option number C, okay? This is the correct answer. Question number 9 is from the chapter Systems of Particles and Rotational Motion, and the question is, a solid cylinder of mass 50 kg and radius 0.5 meter is free to rotate about horizontal axis. A massless string is wound round the cylinder with one end attached to it and the other hanging freely. Tension in the string required to produce an angular acceleration of 2 revolutions per second square. Okay, so suppose this is the solid cylinder. Mass of the cylinder M is given as 50 kg. Radius of the cylinder R is given as 0.5 meter. Okay. Now a massless string is wound round the cylinder like this. Okay. One end of the string is attached to the cylinder and the other end is hanging freely. Suppose this is the freely hanging end of the string. We have to find the tension in the string that will be able to produce an acceleration, angular acceleration of 2 revolutions per second square. So we know that one revolution is equal to 2 pi radian per second square. So 2 revolutions will be equal to 2 into 2 pi, that means 4 pi radian per second square. Okay, so this is the angular acceleration. Now if we look at this cylinder from this side, okay, so it will look like this. This is the radius R and this is the hanging string. Okay, from any one of the side, if we see, it will look something like this. So we have to find out the tension, right? We know that the torque is equal to I into alpha. Okay, so torque is also written as tension into radius. So that will be equal to I into alpha. So tension we have to find out, that will be equal to I into alpha upon R. Okay, now what will be the I? Moment of inertia, that will be equal to mr square by 2. Okay, so let's put the value. I is equal to mr square by 2 into alpha is 4 pi upon this R. Okay, so this R will cancel this and this 2 will cancel this 4 with 2. Okay, 2 into 2 is 4. So what is left? M, that means 50 kg, into R, that is 0.5 meter, into 2 into pi, that is 3.14. Okay, so on solving this, we'll get 157 and the unit of tension will be Newton. Okay, so 157 Newton, that means option D will be the correct answer. Question number 10 is again from the chapter Systems of Particles and Rotational Motion, and the question is, the ratio of the acceleration for a solid sphere of mass m and radius r rolling down an incline of angle theta, this is theta, without slipping, and slipping down the incline without rolling is. Okay, so we know that for a body that is slipping without rolling, that means only slipping, the acceleration is given as g sine theta. Okay, for the slipping body, the acceleration is g sine theta. Similarly, for the body that is rolling without slipping, acceleration will be equal to g sine theta upon 1 plus k square by r square. Okay. Now, moment of inertia is equal to mk square. So, k square will be equal to I by m. And what will be the value of I, that is moment of inertia for a solid sphere? It will be 2 by 5 mr square. Okay. So, 2 by 5 mr square by m. So m will be cancelled. So k square will be equal to 2 by 5 r square for a solid sphere. Okay. So let's put this value here in this equation. So it will be equal to g sine theta upon 1 plus k square is equal to 2 by 5 r square, and here also we had r square already. Okay. So r square cancelled. Here we'll get, on solving this, 1 plus 2 by 5 will get 5 by 7 g sine theta. Okay. Now we have to find the ratio. So ratio of the body, the solid sphere that is rolling without slipping, that means rolling by the acceleration in case of slipping. Okay, this ratio we have to find out. So this is 5/7 g sine theta, and for slipping it is only g sine theta. So g sine theta will be cancelled. The ratio will be 5/7, that is 5:7. So the correct answer will be option number A. Question number 11 is from the chapter Gravitation, and the question is, a black hole is an object whose gravitational field is so strong that even light cannot escape from it. To what approximate radius would Earth have to be compressed to be a black hole? Okay, so we know that if the escape velocity will be less than the velocity of the light or the speed of the light, in that case light will escape. Okay, light will escape. But it is given that even light is unable to escape. For that, the escape velocity must be equal to or greater than the speed of the light. Okay, then only light will be unable to escape. So at least it should be equal. At least the escape velocity should be equal to the speed of the light. Okay, so we know that the escape velocity is given by the formula under root 2 gm upon r. So that will be equal to the speed of the light c. So squaring both sides will get 2 gm upon r equals to c square. We have to find this radius of the earth. Okay. So radius will be equal to 2 gm upon c square. Okay. So 2 gm, that means 2 into g is the gravitational constant whose value is 6.67 into 10 to the power minus 11 into mass of the earth is given here in the question, 5.98 into 10 to the power 24 kg upon c square, that means square of 3 into 10 to the power 8. Okay. So on solving this, you will get 8.86 into 10 to the power minus 3 meter. So in the options you can see there is an approximate value. Since 10 to the power 3 is not given here, so the nearest value will be 10 to the power minus 2 meter. Okay. So option C will be the correct answer. Question number 12 is from the chapter Gravitation, and the question is, dependence of intensity of gravitational field E of Earth with distance r from center of the earth is correctly represented by. Okay. So if we talk about the gravitational field outside the surface of the earth, it is equal to gm upon r square. That means the gravitational field is inversely proportional to the square of the distance, right? Now, what about the surface of the earth? So at the surface of the earth, this distance will become equal to the radius. That means the gravitational field will be equal to gm upon capital R square, where r is the radius. Okay. So in this case, electric field is inversely proportional to the square of radius. Okay. Now, inside the surface of the earth, what happens? Inside the gravitational field becomes gm into r upon capital R cube. Okay, this capital R is the radius and small r is the distance at which we are finding out the gravitational field. So from here we can say that the gravitational field is directly proportional to this distance if we talk about the inside of the earth, okay, or inside the surface. So if we plot a graph, first of all we have to keep in mind that the gravitational force is an attractive force. Okay, it is an attractive force. Therefore, we have to consider it as a negative force. Okay, that means the graph will be plotted on the negative side. Okay, so it will be from the center to the radius, it will be directly proportional. Okay, inside it will be directly proportional, so it will go like this. Okay, suppose this is the radius r, so it will go like this, and after that, that means outside the surface, it will become inversely proportional to the square of the distance, so it will be a curved like portion after that. Okay, so according to this, the correct graph will be the first one. Okay, this is the same graph from center to the radius, that means inside the surface. From here to here it is inside the surface, and from here to here it is outside. So according to the equation, this is the correct graph. But Sometimes the negative graph is not given in the options. In that case, option B can be the correct answer. But since negative one is given, so this will be the most appropriate one. So option A will be the correct answer. Question number 13 is from the chapter Mechanical Properties of Solids, and the question is, copper of fixed volume V is drawn into wire of length L. When this wire is subjected to a constant force F, then the extension produced in the wire is M. Which of the following graph is a straight line? Okay, so we know that the Young's modulus is equal to stress upon strain, right? Now stress is equal to force per unit area and strain is equal to change in length upon the original length. Okay. So on putting these values, Young's modulus will be equal to F into L upon A into delta L. Now we can write it in terms of volume by multiplying and dividing both sides by L. Okay. So it will become FL square, and this side area into length will become volume. Okay. So volume into delta L. Right. Now in the options you can see we have to find the relation between delta L and L. So let's bring this delta L on the left hand side. So delta L will be equal to FL square upon Y into V. Okay. So from this equation we can say that the delta L is directly proportional to the L square. So this should give the straight line. Okay. Straight line graph. That means delta L versus L square, option number B will be the correct answer. Question number 14 is from the chapter Mechanical Properties of Fluids, and the question is, a certain number of spherical drops of liquid of radius small r coalesce to form a single drop of radius capital R and volume V. If T is the surface tension of the liquid, then. Okay, so initially there were n numbers of small spherical drops. Okay, each of radius small r. So what will be the surface area? Initial surface area will be equal to 4 pi small r square for each of the spherical drops, and for n number of spherical drops it will be n times 4 pi r square. Similarly, when these drops combine to form a single large drop of radius capital R, then the surface area, that is the final surface area, will become 4 pi capital R square. Okay. Now during this process of conversion of small drops into the single large drop, the energy is absorbed, and we know that energy is equal to surface area into surface tension. Okay. So the energy absorbed will be equal to the change in surface area, that is final surface area minus initial surface area into the surface tension. Okay. The final surface area is 4 pi capital R square and initial surface area is n times 4 pi small r square into the surface tension. Now if we multiply and divide the surface area by the radius, then we can get the volume. Okay. So let's do this. 4 pi capital R square into capital R will become R cube, and similarly we are dividing by the radius also. This side also n times 4 pi R cube on multiplying upon small r by dividing. Okay, into T. Now we know that 4 by 3 pi r cube is equal to the volume. So 4 pi r cube will be equal to 3 times the volume. Okay. So in place of 4 pi r cube, we can put 3 times the volume. Okay. So it will become 3V upon capital R minus this side also the total volume will be same. So it will be 3V. So 3V upon small r into the surface tension. So from here we can take 3V and T common, and this side what will be left under bracket? 1 by capital R minus 1 by small r. So this is the energy absorbed. Okay, energy absorbed. But in the options the energy released is mentioned, so it will be just the opposite. The sign will reverse. Okay, so energy released will become 3VT 1 by small r minus 1 by capital R. Okay, just the opposite sign. So let's see which is the correct relation. 3VT 1 by small r minus 1 by capital R is released. So option C will be the correct answer. Okay, if energy absorbed was mentioned, then capital R would come first. Okay, but here option C is the correct answer. Question number 15 is from the chapter Thermal Properties of Matter, and the question is steam at 100 degrees Celsius is passed into 20 grams of water at 10 degrees Celsius. When water acquires a temperature of 80 degrees Celsius, the mass of water present will be, okay, specific heat of water is given and the latent heat of steam is given. So we have steam at 100 degrees Celsius and we have water at 10 degrees Celsius, okay. When the steam is passed into water, what will happen? Heat will transfer from higher temperature to lower temperature. That means from the steam to water. Okay. So during this process, the steam will lose heat, whereas the water will gain heat, and the temperature of water will rise. Okay. In this question, it is asked that when the temperature of water reaches 80 degrees Celsius, initially it was 10 degrees Celsius. When it reaches 80 degrees Celsius, at that point of time, what will be the mass of water present? Okay, because some of the steam will get converted into water, so the mass of water will increase. Okay, now first we'll talk about the loss of heat by the steam. Okay, loss of heat by steam. So it will take place in two steps. First, the 100 degrees Celsius steam will get converted into 100 degrees Celsius water. So during this step, there will be only phase change. Okay. And after that, 100 degrees Celsius water will get converted into 80 degrees Celsius water. So during this step, there will be only temperature change and no phase change. Okay. Now, what will be the heat loss during the first step? Let's say Q1, that will be equal to M into L, because during the phase change, the heat lost is M into L. Okay. Mass of the steam is not given, so we'll write M only, but the latent heat of steam is given as 540 calorie per gram. So it will be 540 M. Okay. This is the heat loss during the phase change. Now heat loss during the temperature change, that is Q2, will be equal to MC delta T. Mass of steam is unknown, so we'll write M only. C, that is specific heat of water, is given as 1 calorie per gram per centigrade, and delta T, that is temperature change, is 20 degrees Celsius, because 100 degrees Celsius to 80 degrees Celsius, that means there is a change of 20 degrees Celsius. Okay, so this is equal to 20 M. Okay, so what will be the total heat loss? Total heat lost by the steam will be 540 plus 20 M, 540 M plus 20 M, that is 560 M. Okay, this is the total heat lost by the steam. Now we'll talk about the gain of heat by water. Gain of heat by water. So water is not undergoing any phase change. It will just increase its temperature from 10 degrees Celsius to 80 degrees Celsius. Okay, so the gain of heat, let's say Q3, will be equal to MC delta T. Here the mass of water is given. So mass of water is 20 grams, specific heat 1, and delta T during this step from during this process 10 degree to 80 degrees Celsius will be 70 degree. Okay, change in temperature is 70 degree. So it will be equal to 1400. Okay, so this is the heat gained by the water. Now, according to the principle of calorimetry, according to the principle of calorimetry, the heat lost by the steam, heat lost by the steam will be equal to heat gained by the water. Okay, so we have seen that the heat lost by the steam is 560 M and the heat gained by water is 1400. Okay, so from here we can say that the value of M is 2.5. Okay, 2.5 gram. So what is this M? This is the mass of the steam that has got converted into water. Okay, so what will be the mass of, or the final mass of water? Final mass of water at this point of time, initially it was 20 grams and now 2.5 grams of steam has also converted to water. Okay, so the final mass is 22.5 grams. Okay, so let's see the options. 22.5 grams is mentioned in the last option, so option D will be the correct answer. Question number 16 is again from the chapter Thermal Properties of Matter, and the question is certain quantity of water cools from 70 degrees Celsius to 60 degrees Celsius in the first 5 minutes and to 54 degrees Celsius in the next 5 minutes. The temperature of the surrounding is. So we'll use the Newton's law of cooling here. Newton's law of cooling. According to this law, theta 1 minus theta 2 by delta T equals to K theta 1 plus theta 2 by 2 minus theta naught. Okay. So theta 1 is the initial temperature here. Initial temperature. Theta represents the temperature. Okay. Theta 2 is the final temperature. Theta naught is the temperature of the surrounding or the room temperature. Okay. So temperature of the surrounding, and delta T represents the time change. Okay. So in the first case, it is given that the certain quantity of water cools from 70 degrees Celsius to 60 degrees Celsius. That means theta 1 in this case is 70 degrees Celsius and theta 2 is 60 degrees Celsius. And time taken is delta T is 5 minutes. Okay. So if we put these values in the above equation, we'll get theta 1 minus theta 2, that is 70 minus 60 by delta T, that is 5 minutes, equals to the constant K theta 1 plus theta 2 by 2, that will be 70 plus 60 by 2, that is 65 minus theta naught. Okay. So let's write it as equation 1. And in the second case, it further cools to 54 degrees Celsius. So this time theta 1 is 60 degrees Celsius and theta 2 is 54 degrees Celsius. And again the time taken is 5 minutes. So delta T is 5. Okay. Again we'll put these values in the above equation. So we'll get theta 1 minus theta 2, that is 60 minus 54 by delta T, that is 5, equals to constant K. Theta 1 plus theta 2 by 2 will be 57 minus theta naught. Okay. Let's write it as equation 2. We have to find the value of theta naught, that is temperature of the surrounding, right? So let's divide equation 1 by equation 2. So on dividing equation 1 by equation 2, on the left hand side this denominator 5 will be cancelled, and on the right hand side K constant will be cancelled. Okay. So what will be left on the left hand side? 70 minus 60, that is 10, by 60 minus 54, that is 6, equals to, on the right hand side we have 65 minus theta naught upon 57 minus theta naught. Okay. We have divided equation 1 by equation 2. So if we can simplify this, it will be 2 into 3, 6, and 2 into 5, 10. So 5 by 3. So let's cross multiply. 5 into 57 minus theta naught equals to 3 into 65 minus theta naught. So 5 into 57 will be equal to 285. Okay. So 285 minus 5 into theta naught, that is 5 theta naught, equals to 3 into 65, that is 195 minus 3 theta naught. So if we bring theta naught on the same side and numbers on the same side, it will be 285 minus 195, that is 90, equals to minus 3 theta naught plus 5 theta naught, that is 2 theta naught. Okay. So from here we can find the value of theta naught. It will be 90 divided by 2, that is 45 degrees Celsius. This is the temperature of the surrounding. So let's see, 45 degrees Celsius. It is given in the first option. So option A will be the correct answer. Question number 17 is from the chapter Thermodynamics, and the question is a monoatomic gas at a pressure P having a volume V expands isothermally to a volume 2V and then adiabatically to a volume 16V. The final pressure of the gas is, we have to take gamma as 5 by 3. Okay. So we can see here that there are two types of expansions taking place. First, there is an isothermal expansion. Isothermal expansion. And then there is adiabatic expansion. Okay. Adiabatic expansion. So in case of isothermal expansion, pressure will increase from P1 to P2. and volume will increase from V1 to V2, right? And it is given that initial pressure is P and initial volume is V, okay? Final volume is 2V. So the volume increases from V to 2V and pressure increases from P to P2. P2 is unknown, okay? So we know that in case of isothermal expansion, PV is constant. PV is constant. That means P1 V1 will be equal to P2 V2. And P1, that is initial pressure, was P, initial volume V1 was V. So PV is equal to the final pressure, that is P2, that is unknown, into final volume, that is 2V. Okay. So from here we can say that the final pressure P2 is equal to initial pressure by 2. Okay. So this is the value of P2. Let's write it as equation 1. Now, in case of adiabatic expansion, the pressure and volume further change. Okay, so this time the pressure will change from P2 to P3 and volume will change from V2 to V3, right? P2, as we have seen, is equal to P by 2. P3 is unknown. This is the final pressure that we have to find out. Now V2 was equal to 2V and V3 is given as 16V. Okay, this is the final volume. So what happens in case of adiabatic expansion? In this case, PV to the power gamma is constant, right? Now P1 into, sorry, this time we have P2. Okay, so P2 V2 to the power gamma is equal to P3 V3 to the power gamma. Okay, so let's put the values. P2 was equal to P by 2 into V2 was 2V. Okay, so 2V to the power gamma. Gamma is given as 5 by 3 in the question. And on the right hand side, P3, that is unknown, and V3 is 16V. So 16V to the power gamma, that is 5 by 3. Okay, so we have to find out the final pressure, that is P3. So P3 will be equal to P by 2, and this 16V will come this side as denominator. So 2V upon 16V to the power 5 by 3. Okay, V is cancelled and 2 by 16 is equal to 1 by 8. So P by 2 into 1 by 8 to the power 5 by 3. So what will be the value of 1 by 8 to the 5 by 3? We know that 1 by 8 can be written as 1 by 2 cube, right? So 1 by 2 cube into 5 by 3, that means 3 is cancelled. So 1 by 2 to the power 5, that means 1 by 32. Okay, so this has the value 1 by 32. So P by 2 into 1 by 32, that is equal to P by 64. This is the final pressure P3. So let's see the options. In the third option we have P by 64. That means option C will be the correct answer. Question number 18 is again from the chapter thermodynamics, and the question is, a thermodynamic system undergoes cyclic process ABCDA as shown in figure. The work done by the system in the cycle is, okay, so we can see that this is a PV graph and we know that the work done is equal to the area under the PV graph, right? Area under the PV graph. So let's see. Under this graph, two triangles can be seen here. Okay, this is the first triangle formed, upper triangle, and this is the second triangle, lower triangle. Okay, so if we add up the areas of these two triangles, we'll find the total area. Okay, so let's find the area of the first triangle, this upper one. So base for this triangle will be CB, that will be equal to 2V0 minus V0, that is equal to V0. Okay, and height is this one, that is equal to 3P0 minus 2P0, that is equal to P0. So what will be the area of this triangle? Area, that means A1 will be equal to half into base into height. So half into V0 into P0, that is equal to V0 P0 by 2. But if you look at the direction of the arrows, you can see that the direction is anti-clockwise, okay, like this. So for anti-clockwise direction, we put a minus sign. So this is the area of the upper triangle. Similarly, we can find the area of the lower triangle. So here again, the base AD will be equal to 2V0 minus V0, that is equal to V0. Okay, so this is the base and height is this one, that is 2 p naught minus p naught, that is equal to p naught again. Okay, so area of the lower triangle, that is A2, will be equal to half into base, that is V naught, into height, that is p naught. So this is equal to V naught p naught by 2, and this time the direction is clockwise. Okay, this is a clockwise direction. If you look at the direction of the arrows, so here will be a positive sign, okay, not negative sign. So the total area will be equal to minus V naught P naught by 2, that is A1, plus A2, that is V naught P naught by 2. So since the magnitudes are same but the signs are opposite, the result will be 0. Okay, this is the total area, that means the total work done. So work done will be equal to 0. That means option D will be the correct answer. Question number 19 is from the chapter Kinetic Theory, and the question is, the mean free path of molecules of a gas of radius small r is inversely proportional to. Okay, so we know that the mean free path lambda is equal to 1 by root 2 pi d square n, where d is the diameter. Okay, so diameter can be written as 2 times the radius, so d square will be equal to 4r square. Okay, so let's put this value 1 by 4 root 2 pi r square n. Okay, so here we have to find the relation between the mean free path, that is lambda, and the radius. Okay, so radius, you can see here that lambda is inversely proportional to the r square. Okay, so inversely proportional is mentioned in the question, so r square, that is option B, will be the correct answer. Question number 20 is from the chapter Waves, and the question is, if N1, N2 and N3 are the fundamental frequencies of the three segments into which a string is divided, then the original fundamental frequency N of the string is given by. Okay, so we know that the fundamental frequency N is equal to 1 by 2L under root T by mu. Now, suppose this is the string which is divided into three segments. So it is not given that it is divided into three equal segments. That means the length of the segments can vary. Okay, suppose this is L1, this is L2, this is L3. So the total length of the string, that is L, will be equal to L1 plus L2 plus L3. Now from this equation we can see that the fundamental frequency N is inversely proportional to the length L. Okay, other things will remain constant. The tension will remain same for each of the segment, and mu is also a constant, so it will remain same. Okay, so 1 by N will be equal to 1 by N1 plus 1 by N2 plus 1 by N3. Okay, so this is the correct relation. That means option A will be the correct answer. Question number 21 is from the chapter Waves, and the question is, the number of possible natural oscillations of air column in a pipe closed at one end of length 85 centimeter whose frequencies lies below 1250 Hz are. Velocity of the sound is 340 meter per second. Okay, so the length of the pipe is given 85 centimeter, that means 85 into 10 to the power minus 2 meter. Okay, and velocity of the sound is given. Now we know that for a closed pipe, the frequencies are in the multiple of odds. That means N0, 3N0, 5N0, 7N0, 9N0, 11N0, and so on. Okay. Now, the fundamental frequency N0 is equal to velocity of the sound V upon 4L. L is the length of the pipe. Okay. So, velocity of the sound is 340 meter per second, divided by 4 into length, that is 85 centimeters. So 85 into 10 to the power minus 2 meter. Okay. Now 4 into 85 is 340. So it will cancel out, and here we'll get 10 to the power 2. That means 100 Hertz will be the fundamental frequency. So this is the fundamental frequency 100 Hertz. So next frequency will be 3 times the fundamental frequency. That means 300 Hertz. Then 5N0, that means 500 Hertz. Then 7N0, that means 700, then 900, then 1100, next will be 1300, right? Next odd will be 1300. So here we have to find how many frequencies lie below 1250. That means Below 1250, only 1, 2, 3, 4, 5, 6 till 1100 it is below 1250, because after that it is more than 1250, that is 1300. So total 6 frequencies are below 1250 Hz. That means option D will be the correct answer. Question number 22 is from the chapter Waves, and the question is: a speeding motorcyclist sees traffic jam ahead of him. He slows down to 36 km per hour. He finds that traffic has eased and a car moving ahead of him at 18 km per hour is honking at a frequency of 1392 Hz. If the speed of the sound is 343 meter per second, then the frequency of the honk as heard by him will be. Okay, so we have to find the frequency of the honk of car. That means car is the source here. Okay, so here the observer is the motorcyclist. Observer is motorcyclist, whereas source is car. Now the speed of the observer is given as 36 km per hour, that means 10 meter per second, whereas the speed of the source is given as 18 km per hour, that is 5 meter per second. Okay, frequency of the source is 1392 Hz. We have to find the frequency that is heard by the observer. That means apparent frequency. That will be equal to the frequency of the source into speed of sound plus minus speed of the observer upon speed of sound plus minus speed of the source. Okay. Now, what is the sign to be put here? So you have to keep the sign convention in mind. For that, just remember that if we talk about the observer, that means the sign on the numerator side, we are using the Doppler's formula, right? This you should know, Doppler's formula. So here on the numerator side, if the observer is moving towards the source, in that case there will be a plus sign. Okay, and if it is moving away from the source, in that case there will be a minus sign. Now if we talk about the source, the direction of the source, that means the sign to be put on the denominator side, in that case the rule will be just opposite. That means if the source is moving towards the observer, there will be a minus sign. Okay, and if it is moving away from the observer, then there will be a plus sign. Okay, just opposite rules. Now let's see. We'll put the values here. Frequency is given as 1392. Speed of the sound is 343 meter per second. Now here observer. That means numerator side, observer is moving towards the source, right? This is the motorcyclist. And it is moving towards the car, right? So there will be a plus sign. And the speed of the observer is 10 meter per second. On the denominator side, speed of the sound 343, and this time again plus sign because the source, that is car, is moving away from the observer. So plus sign again. Okay. And the speed is 5 meter per second. So let's put the values. 1392 into 343 plus 10, that means 353, upon 343 plus 5, that means 348. So this 348 into 4 will be equal to 1392. So there is a 4 here, and 353 into 4, that means 1412 Hertz. This is the frequency that is heard by the observer. So option C, 1412 Hertz will be the correct answer. Question number 23 is from the chapter Electrostatic Potential and Capacitance, and the question is: two thin dielectric slabs of dielectric constants K1 and K2, where K1 is less than K2, are inserted between the plates of a parallel plate capacitor as shown in the figure. The variation of electric field E between the plates with distance D as measured from plate P is correctly shown by. Okay, so there is a parallel plate capacitor. This is plate P and this is plate Q. Okay, there is a dielectric slab here with the dielectric constant K1, and there is a dielectric slab with the dielectric constant K2. Okay. Now in between the plate and the dielectric slab there will be air. Also in between the two dielectric slabs there will be air. Okay. Now we have to plot a graph showing the variation of electric field with the distance. Okay. So suppose the electric field in the presence of air is this much. Okay. So in the regions where the dielectric slab is present, there the electric field will vary. Now it will either increase or decrease. So that will depend on the formula. We know that electric field is equal to sigma upon epsilon naught in the absence of dielectric medium. Okay. In the absence of dielectric medium. But in the presence of dielectric medium, electric field is equal to sigma upon K epsilon naught in the presence of dielectric medium. So we can say that the electric field is inversely proportional to the dielectric constant K. So if the dielectric medium is present, the electric field will decrease as compared to that in the air. Okay. So here you can see in the air, it is this much. Then comes the dielectric constant K1. So it will decrease to some extent. It will decrease to some extent. Again there is air. So it will again increase. Okay, in this region where air is present, and again there is a dielectric medium with constant K2, so it will again decrease. But how much it will decrease? It is given that K1 is less than K2. Okay, that means it will decrease to a much greater extent. Okay, K2 is greater, so it will decrease to a much greater extent in case of K2, and then again it will increase in case of air. Okay, so this is the type of graph that will be received. Okay, like this: decreased, then increased, then again decreased to a greater extent, and then again increased. So this is what the graph will look like. So let's see, in the first option there is no such graph, because here it is shown that it is increasing in case of dielectric constant, so it is incorrect graph. Okay, then in the next one, first it is decreasing but then it is increasing, which is again incorrect. Okay, because in both the dielectrics case it will decrease. Now in the third graph, this is the same graph that we have discussed. Okay, in case of K1 it decreased to certain level, and in case of K2 it decreased to much greater level because K2 was greater than K1. Got it? And in the last graph there is no such variation, so the third is the most appropriate graph. Option C will be the correct answer. Okay. Question number 24 is from the chapter Electrostatic Potential and Capacitance, and the question is: a conducting sphere of radius r is given a charge q. The electric potential and the electric field at the center of the sphere respectively are. Okay, so this is a direct question. When a conducting sphere of radius r is given a charge q, in that case the electric potential becomes q by 4 pi epsilon naught r. Okay, and the electric field at the center of the sphere is 0. Okay, so the correct answer will be option number B. Question number 25 is from the chapter Electric Charges and Fields, and the question is: in a region the potential is represented by Vxyz equals to 6x minus 8xy minus 8y plus 6yz, where V is in volts and xyz are in meters. The electric force experienced by a charge of 2 coulomb situated at point 111 is. Okay, so the potential V is given as 6x minus 8xy minus 8y plus 6yz, right? And we have to find the electric field first. Okay, so the value of electric field will be equal to minus dV by dr, where V is the potential in volts and R is the distance in meters. Okay, and that will be equal to minus dV by dx I cap plus dV by dy j cap plus dV by dz k cap. Okay, that means we have to differentiate the x, y and z terms separately. Okay, so let's find out the value of dV by dx here. So that will be equal to the differentiation of the first two terms only, because x is present in the first two terms and others will be 0. Okay, so it will be equal to 6 minus 8y. Similarly, the value of dv by dy will be equal to minus 8x minus 8 plus 6z, and the value of dv by dz will be equal to 6y. Okay, so let's put these values here. The electric field, here we are finding out the vector electric field, okay, vector E. So that will be equal to minus dv by dx, that means 6 minus 8y I cap, plus dv by dy, that means minus 8x minus 8 plus 6z j cap, plus dv by dz, that is 6y k cap. Okay, now we have to find the electric force at the point 1, 1, 1. Okay, that means at this point the value of x is 1, the value of y is 1, and the value of z is also 1. So let's put these values here. Minus 6 minus 8y, that means minus 2. So minus 2 I cap. Similarly this side we have minus 10 j cap, and this side plus 6 k cap. Now if we remove the minus and if we remove the bracket from here, it will become minus minus plus. So 2 I cap, again minus minus plus 10 j cap, and minus plus minus 6 k cap. Okay, so this is the value of vector E. Now what will be the magnitude of vector E? That means magnitude of electric field, that will be equal to 2 square plus 10 square plus minus 6 square and root of this. Okay, so here 2 square is 4, 10 square is 100, and minus 6 square is 36. So under root 140. Okay, and that can be written as 2 root 35. So this is the value of electric field. Now we can find out the force, that is equal to charge into electric field. Okay, so charge is given as 2 coulomb, and electric field we have calculated 2 root 35. So the force will be 2 into 2, that is 4 root 35. Okay, and the unit of force will be Newton. So the correct answer will be 4 root 35. That means option number D is the correct answer. Question number 26 is from the chapter Current Electricity, and the question is, two cities are 150 km apart. Electric power is sent from one city to another city through copper wires. The fall of potential per kilometer is 8 volt and the average resistance per kilometer is 0.5 ohm. The power loss in the wire is, okay, so it is given that the fall of potential per kilometer is 8 volt, but here the total distance is 150 kilometer. So the potential for 150 kilometer will be equal to 8 into 150 volt. Okay, so on multiplying this we'll get 1200 volt. So this is the total potential. Similarly, the average resistance per kilometer is 0.5 ohm, but the total distance is 150 kilometer. So the resistance for 150 kilometer will be equal to 0.5 into 150 ohm. Okay, that is equal to 75 ohm. This is the total resistance. Now we have to find out the power loss in the wire. So power loss is equal to V square by R. V is equal to 1200 volts, so V square, that means 1200 into 1200 upon the resistance, that is 75. So 12 into 12 is 144 into 40, that means 10 to the power 4 upon 75. So this will be equal to 1.92 into 10 to the power 4. So it can be written as 19.2 into 10 to the power 3, and the unit is watt. So 19.2 into 10 to the power 3 watt, that can be written as 19.2 kilowatt. Okay, so the correct option will be 19.2 kilowatt. That means option number B. Question number 27 is again from the chapter Current Electricity, and the question is, the resistance in the two arms of the meter bridge are 5 ohm and R ohm respectively. When the resistance R is shunted with an equal resistance, the new balance point is at 1.6 L1. The resistance R is, okay, so initially as shown in this figure, we have two resistances, 5 ohm resistance and R ohm resistance. Now, if this is the balance point, on the left side the length is L1 and on the right side the length is 100 minus L1. Okay, this is the first case. So for this case, that is case 1, 5 by L1 will be equal to R by 100 minus L1. So let's write it as equation number 1. Now in the second case, it is given in the question that the resistance R is shunted with an equal resistance. That means this is the 5 ohm resistance, this is the R ohm resistance. So another R ohm resistance is connected in parallel to this. Okay, so the equivalent resistance will be equal to R by 2 because this is parallel combination. Okay, and if this is the balance point, so this side the length is L2 and this side 100 minus L2. So we can write the equation for this: 5 by L2 equals to R by 2 by 100 minus L2. And it is given that the new balance point, that means L2, is equal to 1.6 L1. Okay, so let's put this value here. 5 by L2, that means 5 by 1.6 L1 equals to R by 2 100 minus L2. Okay, so let's further solve it. It will be 5 by L1 equals to 1.6 will move here. So 1.6 R by 200 minus L2. So 2 into 0.8 is equal to 1.6. So 0.8 R by 100 minus L2. Okay, so let's write it as equation number 2. Now you can see in the equation number 1 and equation number 2, both on the left hand side we have 5 by L1. That means both these equations are equal. Okay, both these values will be equal. Okay, equation 1 equal to equation 2. That means the right side will also be equal. So right side in equation 1 is R by 100 minus L1. So R by 100 minus L1 will be equal to the right side in equation 2, that is 0.8 R by 100 minus L2. Okay, and L2 is equal to 1.6 L1. So let's put this value. R is cancelled. Okay, so 1 by 100 minus L1 equals to 0.8 by 100 minus 1.6 L1. So if we solve it, we'll get the value of L1. Okay, so let's cross multiply. It will be 100 minus 1.6 L1 equals to 0.8 into 100 minus L1, that means 80 minus 0.8 L1. Okay, so 100 minus 80 equals to minus 0.8 L1 plus 1.6 L1. That means 0.8 L1 equals to 20. So L1 will be equal to 20 divided by 0.8. That means it will be equal to 25. Okay, so 25 centimeter is the balance point L1. But we have to find out the value of resistance R. So if we put this value in the equation 1, so putting L1 equals to 25 in equation 1, will get 5 by L1, that means 5 by 25 equals to R by 100 minus L1, that means 100 minus 25. So 5 by 25, that means 1 by 5. So 1 by 5 equals to R by 75. So from here we can find the value of R, that is equal to 75 divided by 5. That means 15 ohm. Okay, so the resistance will be equal to 15 ohm. So let's see the options. Here you can see in the second option 15 ohm is given, so option B will be the correct answer. Question number 28 is also from the chapter Current Electricity, and the question is: a potentiometer circuit has been set up for finding the internal resistance of a given cell. The main battery used across the potentiometer wire has an EMF of 2 volt and a negligible internal resistance. The potentiometer wire itself is 4 meter long. When the resistance R is connected across the given cell has values of first infinity and second 9.5 ohm. The balancing lengths on the potentiometer wire are found to be 3 meter and 2.85 meter respectively. That means L1 is 3 meter and L2 is 2.85 meter. The value of internal resistance of the cell is, okay. So although the question is quite lengthy, but the solution is simple. We know that the direct formula for the internal resistance R is equal to L1 by L2 minus 1 into the external resistance R. Okay, so let's put the values. L1 is 3 meter and L2 is 2.85 meter minus 1 into the external resistance is 9.5 ohm. Okay, so if we solve it, 2.85, here we have 3 minus 2.85 into 9.5. So 3 minus 2.85, that means 0.15 divided by 2.85 into 9.5. So on solving this, we'll get 0.5 ohm. Okay, that means option C will be the correct answer. Question number 29 is from the chapter Magnetism and Matter, and the question is, following figures show the arrangement of bar magnets in different configurations. Each magnet has magnetic dipole vector m. Which configuration has highest net magnetic dipole moment? Okay, so we know that the net magnetic dipole moment m net is equal to m1 square plus m2 square plus 2m1 m2 2m1 m2 cos theta. Okay, so here it is given that the each magnet has same magnetic dipole, that is vector m. So m1 is equal to m2, that is equal to m. Okay, so let's put this value here, m square plus m square plus 2m1 m2, that means 2m square cos theta. Okay, so from here we can see that cos theta should be maximum for the maximum magnetic dipole moment. Okay, now we know that the magnetic moment is a vector quantity. It is a vector quantity with the direction south to north. Okay, so if we draw the graph for these configurations, the first one will be like this. Okay, this is south, so south to north, right? And in the second case, it will be in this direction, south to north in the lower portion, and in the upper portion, south to north, that means in this direction. Similarly, for the third graph, it is like this, south to north, and the angle is 30 degree. Whereas the fourth one, you can see the angle is 60 degree. Okay, the angle is 60 degree and the direction is same, south to north. Now, if we find the value of cos theta for the first one, here the theta is 90 degree. So cos 90 degree is equal to 0. For the second option, this is 180 degree. So cos 180 degree is equal to minus 1. Third one, cos 30 degree is equal to root 3 by 2. That will be approximately 0.85. Okay. And in the last one, cos 60 degree, that is half. So we can write it as 0.5. Now, in which case cos theta is maximum? In the third one, 0.85. Okay. In the second one, this is minus 1. So this is minimum. And maximum in the third option, 0.85. So the third option, option C, will be the correct answer. Okay. This configuration will have the highest net magnetic dipole moment. Question number 30 is from the chapter Current Electricity, and the question is, in an ammeter, 0.2% of main current passes through the galvanometer. If resistance of galvanometer is G, the resistance of ammeter will be. Okay, so suppose this is the galvanometer, and we know that the galvanometer is always connected in parallel with the resistance of the ammeter. So this is the resistance of ammeter R. Okay, this is the current I. Now it is given in the question that only 0.2% of the main current passes through the galvanometer. That means the current that passed through the galvanometer, that is Ig, is 0.2% of the current I. Okay, that means 0.2 by 100 I. Okay, so what will be the remaining current? Remaining current will be equal to total current I minus the current that passed through the galvanometer, that is 0.2 by 100 I. Okay, so on solving this, we'll get 99.8 by 100 I. So this remaining current will pass through the resistance of the ammeter. Okay, it will come down. Here this current will be equal to 99.8 by 100I. Okay, now we know that since galvanometer and this resistance R are connected in parallel, therefore they will have the same potential or voltage. Okay, so G and R are in parallel combination. Therefore, voltage across the galvanometer will be equal to voltage across the resistance R. Okay, and voltage is equal to current into resistance. So current in the galvanometer is 0.2 by 100I into the resistance of the galvanometer is given as G. Okay. Similarly, this side, the current that passed through the resistance R is 99.8 by 100I and the resistance is R. Okay. So 100 will be cancelled, I is cancelled. Now on solving this, we get G equals to 99.8 by 0.2 R. Okay. That is equal to 499 R. Okay, so G is equal to 499 R, or we can write that R equals to G by 499. Okay, because here we have to find in terms of G. Okay, so let's say this is equation number 1. So understood till now? Now we have to find the equivalent resistance. So equivalent resistance will be equal to G into R upon G plus R, because this is a parallel combination. Okay. So G into R, and R is equal to G by 499, right? Upon G plus R. That means G plus G by 499. So if we solve this, we'll get G square by 499 here on the numerator side, and on the denominator side we'll get 500G upon 499. Okay, so 499 will be cancelled. Here we have 1G will cancel here, so G by 500. So the equivalent resistance is equal to G by 500. Let's see the options now. Option number C will be the correct answer, 1 by 500 into G or G by 500. Question number 31 is from the chapter Magnetic Effects of Current, and the question is, two identical long conducting wires AOB and COD are placed at right angle to each other with one above the other such that O is the common point for the two. The wires carry I1 and I2 currents respectively. Point I, this is point P, okay? Point P is lying at a distance D from O along a direction perpendicular to the plane containing the wires. The magnetic field at the point P will be. So let's draw the diagram. We have two wires. The first wire is AOB. Suppose this is the wire AOB. And this is the wire COD. These two are placed perpendicular to each other. That means if AOB is lying along the x-axis, then COD will be lying along the y-axis, right? But these two are in the same plane. Now, the wire AOB carries the current I1 and COD carries the current I2. It is already given in the question. Another thing that is given in the question is that there is a point P which is lying at a distance D from O along a direction perpendicular to the plane. So this point P must be lying along the Z axis. Okay. So this is the point P. It is at a distance D from point O. Okay. This is D distance. We have to find the magnetic field at the point P. We know that the magnetic field due to the long current carrying conductor will be equal to mu naught I by 2 pi into D, where D is the distance of that point. Okay. So here two types of magnetic field will be there. One due to the wire AOB and the other due to the wire COD. So we know that the wire AOB is perpendicular to the wire COD. So the magnetic field due to AOB, that is B1, will also be perpendicular to the magnetic field due to the wire COD, that is B2. Okay, so B1 and B2 will be perpendicular to each other. So if you can apply the right hand thumb rule, you can see that due to the wire AOB, the magnetic field will be downwards, okay, in the downward direction. So if this is the point P, here the magnetic field will be somewhere here, okay, whereas the magnetic field due to the wire COD will be in the upward direction like this. Okay, so these two will be perpendicular to each other. This is B1, this is B2. B1 and B2 will be perpendicular to each other. So the net magnetic field will be equal to under root B1 square plus B2 square. So let's put the values here. B1 is equal to mu naught I1 by 2 pi d, and B2 is equal to mu naught I2 by 2 pi d, and we have squares of both. Since mu naught by 2 pi d is common, so we can take them outside the bracket, outside the root. So it will be mu naught by 2 pi d, and under root there will be I1 square plus I2 square. Okay, so we can write it in modified form, that is mu naught by 2 pi d I1 square plus I2 square to the power half. Half means root. Okay, so if you look at the option, the correct option will be the last one. Option number D will be the correct answer. Question number 32 is from the chapter Electromagnetic Induction, and the question is, a thin semicircular conducting ring PQR of radius r is falling with its plane vertical in a horizontal magnetic field B as shown in the figure. The potential difference developed across the ring when its speed is V is. Okay, so the magnetic field is horizontal. It is shown by the cross sign. That means it is inside the plane. Okay, now the ring PQR is moving in a vertical direction. So suppose this is the direction in which this ring is moving with the velocity v. The effective length of this ring will be equal to PR, that means 2 times the radius, right? Now we have to find the potential difference that develops across the ring. So the potential difference or the EMF will be equal to B, that means magnetic field, into V, that is velocity, into the effective length L. Okay, and we know that the effective length is equal to 2 times the radius, so BV into 2R. So we can write it as 2R BV. Now if you look at the options, you can see that only in the last option this value is given, so it is quite obvious that option D is the correct answer. But we also have to determine the point that is at higher potential, so we can apply the right hand rule to this. Right hand rule. So if you apply this rule in this case, so you can find that the direction of the current will be from P to R. Okay, I is the current here. So when the current is flowing from P to R, that means the electrons will be flowing from R to P. So the point P will have the negative charges and the point R will get positive. Okay, it will have positive charges. That means point R will be at higher potential. Higher potential. So now this is confirmed that option D is the correct answer. Question number 33 is from the chapter Alternating Current, and the question is, a transformer having efficiency of 90% is working on 200 volt and 3 kilowatt power supply. If the current in the secondary coil is 6 ampere, the voltage across the secondary coil and the current in the primary coil respectively are. Okay, so what are the things that are given here? Let's write them down first. So the efficiency is given as 90%. So 90 by 100 can be written as 0.9. Then it is working on 200 volt. That means the voltage in the primary coil is given as 200 volt and the power is given as 3 kilowatt. That means input power is given as 3 kilowatt, or we can write 3000 watt. What else is given? The current in the secondary coil, that means IS is given as 6 ampere. Now we have to find the voltage across the secondary coil, that means Vs, and the current in the primary coil, that is IP. So let's first talk about the primary coil. So here we know that power is equal to voltage into current, and the input power is given as 3000 watt. Input voltage is given as 200 volt. So we can find out the input current from here, or the current in the primary coil. So that will be equal to 3000 divided by 200, that means 15 ampere. Okay, so current in the primary coil is 15 ampere. Now we have to find the voltage across the secondary coil. Okay, so we can use efficiency for that. We know that efficiency is equal to output power by input power, right? Input power. Output power is equal to output voltage or the voltage across the secondary coil into the current in the secondary coil. Okay, upon input power is already given here, 3000 watt, and the current in the secondary coil is also given 6 ampere. So we can put this value. Efficiency is 0.9, that is equal to voltage across the secondary coil into the current in the secondary coil, that is 6 ampere upon 3000. So from here we can find out the value of voltage across the secondary coil, that means 0.9 into 3000 divided by 6. Okay, so here we have 3 into 20, 60. 3 into 3 is 9, then 1 0 cancelled. Then on solving this we get 450 volt. Okay, so here first we have to tell what is the voltage across the secondary coil, so that is 450 volt, and then current in the primary coil, that is equal to 15 ampere. Okay, so 450 volt and 15 ampere will be the answer. So let's see, 450 volt and 50 ampere, that means option B will be the correct answer. Question number 34 is from the chapter Electromagnetic Waves, and the question is, light with an energy flux of 25 into 10 to the power 4 Weber per meter square falls on a perfectly reflecting surface at normal incidence. If the surface area is 15 centimeters square, the average force exerted on the surface is. Okay, so the energy flux is given, that means intensity is given. Okay, this is the intensity I. Okay, and then surface area, that is A, is given. We have to find the average force exerted on the surface. So for that we have a direct formula. Force is equal to 2 into intensity into surface area upon the speed of light c. Okay, so let's put the values. 2 into intensity is given as 25 into 10 to the power 4 Weber per meter square into surface area is 15 centimeters square, so it can be written as 15 into 10 to the power minus 4 meter square. Okay, divided by the speed of light, that is 3 into 10 to the power 8 meter per second. So on solving this you will get 250 into 10 to the power minus 8, and the unit will be Newton for force, and it can be written as 2.5 into 10 to the power minus 6 Newton. So the correct answer will be option number B. Question number 35 is from the chapter Wave Optics, and the question is, a beam of light of lambda equals to 600 nanometer from a distant source falls on a single slit 1 millimeter wide, and the resulting diffraction pattern is observed on a screen 2 meter away. The distance between the first dark fringes on either side of the central bright fringe is. Okay, so what is given? The wavelength or lambda is given as 600 nanometer, that means 600 into 10 to the power minus 9 meter. Then width of the slit, that is small d, is given as 1 millimeter, that is 10 to the power minus 3 meter, and capital D is given as 2 meter. We have to find the central maxima. So the central maxima x will be equal to 2 into lambda into capital D divided by small d. Okay, so let's put the values. 2 into lambda, that means 600 into 10 to the power minus 9 meter, into capital D, that is 2 meter, divided by small d, that is 10 to the power minus 3 meter. So all are in meters. So on solving this you will get 2400 into 10 to the power minus 6 meter, which can be written as 2.4 into 10 to the power minus 3 meter, and 10 to the power minus 3 meter means 1 millimeter, so it can be written as 2.4 millimeter. That means option D, 2.4 millimeter, will be the correct answer. Question number 36 is again from the chapter Wave Optics, and the question is, in the Young's double slit experiment, the intensity of light at a point on the screen where the path difference is lambda is k, lambda being the wavelength of light used. The intensity at a point where the path difference is lambda by 4 will be, okay. So it is given that when the path difference, that is delta x, is equal to lambda, in that case the intensity, that is I1, is equal to k. And it is asked that when the path difference becomes lambda by 4, in that case what will be the intensity. So we have to find the intensity in the second case, that is I2. Okay. Now let's talk about the first case, case 1. In this case, what is given? Path difference delta x is equal to lambda. So what will be the phase difference? We know that phase difference is equal to 2 pi by lambda into path difference. Okay. So let's put the value of path difference here, 2 pi by lambda into lambda. That means 2 pi. So in the first case, the phase difference is equal to 2 pi. Now we can find out the intensity. I1 is equal to, we know that the intensity at any point is given by the formula 4 I naught cos square phi by 2. Okay. So in this case, phi is equal to 2 pi, right? So 4 I naught cos square 2 pi by 2. That means 4 I naught cos square pi. Now pi means 180 degree. We know that cos pi, that means cos 180 degree, is equal to minus 1. So cos square pi will be equal to square of minus 1, that is 1. Okay. So that is equal to 4 I naught. And in the question it is given that in this case the intensity is k. That means 4 I naught is equal to k. Okay. Let's write it this equation number 1. Okay. Now let's come to the second case, case 2. In this case, the path difference is given as lambda by 4. So similarly, we'll find out the phase difference first. So phase difference is equal to 2 pi by lambda into path difference, that is lambda by 4. So this is equal to, lambda will be cancelled, 2 into 2 is 4, pi by 2. Okay, so in this case, the phase difference is pi by 2. Now we'll find out the intensity, that is I2. So intensity is equal to 4 I naught cos square phi by 2, that means lambda by 2 into 2, okay, lambda by 4, okay, and 4 I naught is equal to k from equation number 1, so k into cos square pi by 4, okay, and we know that cos pi by 4 is equal to 1 by root 2, so cos square pi by 4 will be equal to 1 by 2, okay, so this is equal to k into 1 by 2, that means k by 2. So in the second case, the intensity will be half the intensity in the first case, okay, k by 2. So let's see the options. Here in the third option you can see k by 2 is given, so option C will be the correct answer. Question number 37 is from the chapter Ray Optics and Optical Instruments, and the question is, if the focal length of objective lens is increased, then magnifying power of option A, microscope will increase but that of telescope will decrease. Option B, microscope and telescope both will increase. Option C, microscope and telescope both will decrease. And option D, microscope will decrease but that of telescope will increase. So let's see, how do we write the magnifying power of a microscope? So that is equal to L upon FO into D upon FE. Okay, so FO is the focal length of the objective lens. Here we can see that the magnifying power of the microscope has an inverse relation with the focal length of the objective, right? That means if the focal length of the objective increases, then the magnifying power of the microscope will decrease. Okay. Similarly, if we talk about the magnifying power of a telescope, so that is equal to FO upon FE. FO is the focal length of the objective lens and FE is the focal length of the eyepiece. So here we can see that the magnifying power has a direct relation with the focal length of the objective lens. That means if the focal length of the objective lens will increase, then the magnifying power will also increase. So for microscope it will decrease, but for telescope it will increase. Okay. So the correct option will be option number D, microscope will decrease but that of telescope will increase. Question number 38 is again from the chapter Ray Optics and Optical Instruments, and the question is, the angle of a prism is A, one of its refracting surfaces is silvered, light rays falling at an angle of incidence 2A on the first surface returns back through the same path after suffering reflection at the silvered surface. The refractive index mu of the prism is, okay, so we have a prism like this. Suppose the surface on the left side is the first surface and the surface on the right side is second surface. Okay, so this second surface is silvered. Okay, it is polished. This is the normal to the surface. Now, the ray of the light will strike the first surface here. It will make an angle that is known as angle of incidence, that is given as 2A in the question. Okay, then it will make an angle R1 after getting refracted from this surface. So this is angle R1. Now after it strikes the second surface, it comes back or returns back through the same path. That means it must have struck the second surface perpendicularly. Okay, it will make an angle of 90 degree at the silvered surface, then only it will return back through the same path. So in this case, what will happen? The angle of emergence will become 0 and R2 will also be 0. Okay, now we know that R1 plus R2 is always equal to the angle of prism, that is A. Here R2 is 0, so R1 will be equal to A. Okay, now we'll use the Snell's law here. Snell's law. So according to this law, mu1 sine I will be equal to mu2 sine R1. Okay, mu1 is the refractive index of the air, that is equal to 1, into sine of angle of incidence, that is equal to 2A, it is given in the question, equals to mu2, that is the refractive index of the material of the prism, that is given as mu in the question, into sine R1, and we have seen that R1 is equal to A. So from here we can write that sine 2A is equal to 2 sine A cos A. This is the formula, trigonometric formula, equals to mu into sine A. So sine A will be cancelled. That means the value of mu is equal to 2 cos A. Okay, this is the refractive index of the material of the prism. Okay, so 2 cos A, that means option B will be the correct answer. Question number 39 is from the chapter Dual Nature of Radiation and Matter, and the question is, when the energy of the incident radiation is increased by 20%, then the kinetic energy of the photoelectrons emitted from a metal surface increased from 0.5 electron volt to 0.8 electron volt. The work function of the metal is, okay, so we know that the kinetic energy of the emitted photoelectrons is equal to HF minus phi, where HF is the energy of the incident photoelectrons. Okay, energy of incident photoelectrons, and phi is the work function that we have to find out. Now it is given that when the energy of the incident photoelectrons, that means HF, is increased by 20%, then the kinetic energy changes from 0.5 electron volt to 0.8 electron volt. Okay, that means in the first case the kinetic energy was 0.5 electron volt, the energy of the incident photoelectrons was HF, and the work function is phi. Let's say this is equation number 1. Now in the second case, this energy of the incident photoelectrons, that is HF, is increased by 20%. Increased by 20%, that is 0.2. Okay, so if initially it was 1, it becomes 1 plus 0.2, that is 1.2. Okay, so in the second equation it will be 0.8 electron volt, that is the kinetic energy, and the energy of the incident photoelectrons is 1.2 HF. Okay, minus work function will remain same. So this is equation number 2. Now we have to solve this to find the work function, that is phi. So let's multiply the first equation by 1.2 so that HF can be cancelled. Okay, so multiplying equation 1 by 1.2, what do we get? If we multiply 0.5 by 1.2, we'll get 0.6, and on the right hand side we'll get 1.2 HF, minus 1.25. Okay, this will become the equation number 1, and the second equation will remain same, that is 0.8 equals to 1.2 HF minus 5. This is second equation. Okay, now if we subtract equation 1 from equation 2, subtracting equation 1 from equation 2, this 1.2 HF will be cancelled. So on the left hand side we'll get 0.8 minus 0.6, that is 0.2, and on the right hand side also we'll get 0.25. Okay, so from here we'll get the value of phi, that is equal to 1. Okay, and the unit will be electron volt. So the work function in this case will be 1 electron volt. That means option B will be the correct answer. Got it? Question number 40 is from the chapter Dual Nature of Radiation and Matter, and the question is, if the kinetic energy of the particle is increased to 16 times its previous value, then the percentage change in the de Broglie wavelength of the particle is. Okay, so we know that the de Broglie wavelength, that is lambda, is equal to h by under root 2me, where E is the energy of the kinetic energy of the particle. Okay, kinetic energy of the particle. So if lambda 1 is equal to h by under root 2 me, then lambda 2 will be equal to h by under root 2m into 16e, because in the second case the kinetic energy is increased to 16 times, so it becomes 16e. Okay, now if we find the ratio lambda 1 by lambda 2, that will be equal to h by under root 2me into under root 2m into 16e upon h. Okay, so h will be cancelled. Now under root 2me is on both the sides, so it will be under root 16 this side. Okay, so under root 16 means 4, other things will be cancelled. So lambda 1 by lambda 2 is equal to 4, that means lambda 2 is equal to lambda 1 by 4. Okay, 1/4 of lambda 1, or you can say 0.25 of lambda 1. Okay, now we have to find the percentage change. So it is quite obvious that there is a change of 75%, but still if we have to find it mathematically, then we can use lambda 1 minus lambda 2 by lambda 1 into 100. Okay, this will be the percentage change. So lambda 1 was lambda minus lambda 2 was 0.25 lambda upon lambda into 100. Okay, so 1 minus 0.25, that means 0.75, and lambda will be cancelled, into 100, that means 75%. So there is a percentage change of 75. Okay, so option B will be the correct answer. Question number 41 is from the chapter Atoms, and the question is, hydrogen atom in ground state is excited by a monochromatic radiation of lambda equals to 975. Number of spectral lines in the resulting spectrum emitted will be. Okay, so here it is given that hydrogen atom is in the ground state, that means the value of n is equal to 1. Okay, so n1 is equal to 1 here, and here we should know that there are several energy levels. So in the ground level n is equal to 1. Okay, then in the next level n equals to 2. Similarly, next level is n equals to 3, and then n equals to 4, and so on. Okay, now the energies of these levels are different. For example, for the first level, that is n equals to 1, the energy is minus 13.6 electron volt. For the next level, the energy is minus 3.4 electron volt. For the third one, it is minus 1.5 electron volt, and for the next one, that is fourth one, it is minus 0.85 electron volt. So since the energies vary in different levels, therefore the difference will also vary. Difference between the first level, that is n equals to 1, and other levels will vary. For example, if we see the difference between the energies of the first and second level, it is 10.2. Okay, by subtracting these energies you can get this difference. Similarly, the difference between n equals to 1 and n equals to 3 is 12.09. Okay, and the difference between n equals to 1 and n equals to 4 is 12.75. Now, here we know that what will happen, since the hydrogen atom is present in the ground level, that is n equals to 1, and it is excited by a monochromatic radiation of lambda equals to 975. So after getting excited, it will move up to higher energy levels, right? But we don't know to which particular level or to which specific level it will move. Okay, so that we have to find out. We know the formula H equals to Hc by lambda. Now the value of Hc is equal to 12420 electron volt angstrom. Okay, and here the value of lambda is given 975 angstrom. So angstrom, and on solving this we'll get 12.75 electron volt. So this much energy is required. Okay, so from here we can see that this is the difference between n equals to 1. This is the difference, energy difference between n equals to 1 and n equals to 4, right? 12.75 electron volt. That means this hydrogen atom will move up to n equals to 4. Okay, so from here we can say that n1 equals to 1 and n2 is equal to 4. Okay, now we have to find the number of spectral lines that will result. Okay, so for that we have a formula: number of spectral lines, number of spectral lines is equal to n into n minus 1 by 2. Okay, where n is n2, to the orbit, to the level at which this hydrogen atom has moved. Okay, so we have to put n equals to 4 here. So 4 minus 1 by 2, and on solving this you'll get 6. Okay, that means the answer will be 6. 6 spectral lines will come out. That means option C will be the correct answer. Question number 42 is from the chapter Nuclei, and the question is: the binding energy per nucleon of lithium and helium nucleon are 5.60 MeV and 7.06 MeV respectively. In the nuclear reaction, this is the reaction, the value of energy Q released is. Okay, so here we know that the total binding energy is equal to binding energy per nucleon into the number of nucleons, right? And number of nucleons is equal to mass number. So for lithium 73, the binding energy per nucleon is given as 5.60 MeV, and number of nucleon, that is mass number, is 7. Okay, so into 7, total binding energy for this will be equal to 39.2 MeV. Okay, now for helium. So for helium 4-2, the binding energy per nucleon is given as 7.06 MeV, and the mass number, that is number of nucleons, is 4. So the total binding energy will be 28.24 MeV. But this is the total binding energy of one helium atom, right? And in the reaction that is given here, you can see that in the product side, on the product side, 2 helium atoms are produced. That means we have to find the binding energy of 2 helium atoms. That means 2 into 28.24, that is equal to 56.48 MeV. Okay, this is the binding energy for 2 helium atoms. Now we have to find the energy Q that is released. So for that we have to subtract the product side minus reactant side. So on the product side we have 56.48 MeV, minus on the reactant side we have one lithium only, that is 39.2 MeV. Okay, hydrogen has 0 binding energy. So the difference will come out to be 17.3 MeV. That means option D will be the correct answer. Question number 43 is again from the chapter Nuclei, and the question is: a radioisotope X with a half-life 1.4 into 10 to the power 9 years decays to Y, which is stable. A sample of the rock from a cave was found to contain X and Y in the ratio 1:7. the age of the rock is. Okay, so we have a radioisotope X that is converted to Y after the radioactive decay. Okay, now initially that means at time t equals to 0, a certain amount of X would be present. Let's say n naught amount of X was present. Okay, and since no decay has taken place yet, so the amount of Y would be 0. Now after some time, after time t, the decay has taken place, so a certain amount of Y would have formed. Okay, so let's say X amount of Y was formed. Okay, so what is the amount of X that is left? That is initial amount and not minus X. Okay, now this ratio of X and Y is given in the question 1:7. That means ratio of n naught minus X upon X is equal to 1 by 7. So from here we can find the value of X. So 7 n naught minus 7x equals to x. So from here 7 n naught equals to 8x. So x equals to 7 n naught by 8. Okay. So this is the value of x, small x, that is amount of y present after time t. So what is the amount of x? Amount of x is equal to n naught minus x, that is n naught minus 7 by 8 n naught, right? So on solving this, we'll get n naught by 8. So it can be written as n naught into 1 by 2 cube, right? That means 3 half-lives were involved. So cube means 3 half-lives have passed, and it is given in the question that the half-life of x is 1.4 into 10 to the power 9. So 3 half-lives means this half-life multiplied by 3. So the total time or the total age of the rock will be, age is equal to 3 into the half-life, that is given as 1.4 into 10 to the power 9 years. So on solving this, you'll get 4.2 into 10 to the power 9 years. Okay, this is the age of the rock. So let's see the options. It is given in the third option, so option C will be the correct answer. Got it? Alright, now question number 44 is from the chapter Semiconductor Electronics, and the question is, the given graph represents VI characteristic for a semiconductor device. Which of the following statement is correct? Okay, so this type of graph is drawn for a solar cell. Okay, 2 points are there, point A and point B. At point A, the amount of voltage is large, but the amount of current is 0. And this is known as an open circuit voltage. Open circuit voltage. At point B, the case is just the opposite. That means there is a large amount of current, but the amount of voltage is 0. So at point B, voltage is 0. And this is known as a short circuit current. Short circuit current. Now let's read these statements. The first statement says it is VI characteristic for solar cell where point A represents open circuit voltage and point B short circuit current. So we have discussed right now, this is a correct statement. Okay. Then the second statement says it is for a solar cell and points A and B represent open circuit voltage and current respectively. So this is incorrect because both can't be open circuit, because in case of open circuit no current flows, but at point B current is flowing, so this cannot be an open circuit condition. Now we come to the third statement. It says it is for a photodiode and points A and B represent open circuit voltage and current respectively. So this type of graph is not drawn in case of photodiode. Let's see what type of graph is drawn in case of a photodiode. This is V, this is I, and the graph will look something like this. Okay, so if you see this type of graph, just understand this is the graph for photodiode. Then the last statement says it is for an LED and points A and B represent open circuit voltage and short circuit current respectively. Again, this is not for an LED because there is a different type of graph that is drawn for LED. Let's see the type of graph. This is V, this is I, and the graph will look like this. Okay, so you should know which type of graph is drawn in which case. So we can say that option A is the correct statement. Okay. And now the last question is again from the chapter Semiconductor Electronics, and the question is the barrier potential of a PN junction depends on first type of semiconductor material. So yes, it depends on semiconductor material. For example, if we talk about germanium, so the barrier potential for germanium is 0.3 volt, whereas for silicon it is 0.7 volt. Okay. Then the amount of doping. So this is also correct. It depends on the amount of doping. As the doping increases, the potential barrier or the depletion width will decrease. Okay. So this is also correct. Now we come to the third one, that is temperature. So it also depends on temperature. Actually, it is directly proportional to temperature. Barrier potential is directly proportional to the temperature. That means as the temperature increases, the potential barrier or the depletion width also increases. So it depends on all three. That means A, B and C. Option D will be the correct answer. Okay. So here we complete all the physics questions from NEET 2014 paper. We'll be back with another session soon. Till then, keep learning, keep scoring high. For a better understanding, I would suggest you to practice same questions from our website www.examsnet.com. And for more information, please download our app from the link given in the description box. Thank you so much. Hey champs of Examsnet, welcome to the question series of Examsnet. I hope this series of detailed explanation is helping you a lot. So in today's session we are going to discuss NEET 2014 chemistry paper, and we are 45 questions here. So let's start the session. First question is from the chapter Structure of Atom, and the question is what is the maximum number of orbitals that can be identified with the following quantum number: n equals to 3, l equals to 1 and m equals to 0. This is 0. Okay. So here the principal quantum number is 3 and azimuthal quantum number is 1. That means we are talking about the 3p orbitals. Okay. So how many orbitals are there in p subshell? There are 3 orbitals. This is 3p x, this is 3p y, and this is 3p z. Okay, so 3 orbitals are there. Now here the possible values of m, possible values of m are minus L to plus L. Okay, that means since L is equal to 1 here, so the possible values of M are minus 1, 0 and plus 1. Okay, so this is minus 1, this is 0, this is plus 1. But all the three values are not mentioned in the question. Only one value is mentioned, that is M equals to 0. So only this orbital can be identified by the given data. Only one orbital can be identified from the given data. Okay, because there are three possible values but only one value is mentioned in the question. So the maximum number of orbitals that can be identified is 1. That means option A will be the correct answer. Question number 47 is again from the chapter Structure of Atom, and the question is calculate the energy corresponding to light of wavelength 45 nanometer. Planck's constant is given and speed of light is given. So it's very simple. We know the formula energy equals to hc by lambda, where h is the Planck's constant. This is Planck's constant. C is the speed of light and lambda is the wavelength. Okay, this is the wavelength of light. So all the values are given here. We just have to put the values. The value of Planck's constant is 6.63 into 10 to the power minus 34 into c, that is speed of light, is 3 into 10 to the power 8. Units are given in the question, right? Upon wavelength lambda, that means 45 nanometer. So 45 nanometer means 45 into 10 to the power minus 9 meter, right? On solving this, you'll get the value 4.42 into 10 to the power minus 18, and the unit of energy is joule. So 4.42 into 10 to the power minus 18 joule will be the answer. That means option number D is the correct answer. Question number 48 is from the chapter States of Matter, and the question is Equal masses of H2, O2 and methane have been taken in a container of volume V at temperature 27 degrees Celsius in identical conditions. The ratio of the volumes of gases H2 is to O2 is to methane would be. Okay. So the temperature is same, that is 27 degrees Celsius, and overall condition is identical. That means both temperature and pressure are same. And we know that at same temperature and pressure, that means at identical conditions, volume is proportional to the number of moles. Now here in this question we have to find the ratio of volume of H2, O2 and methane. So in place of this ratio we can write the ratio of number of moles of H2, O2 and methane. We know that the number of moles is equal to the given mass upon molar mass. And it is given in this question that these have equal masses, right? So if we assume that the mass of hydrogen is 1, then the mass of oxygen will also be 1 and that of methane will also be 1. So let's take the given mass as 1 for all. So 1 by, what is the molar mass of hydrogen? It is 2. Then for oxygen, the mass, given mass we have assumed is 1 and the molar mass is 16 into 2, that is 32. And for methane, given mass is 1 and the molar mass is 16. Okay. Now it is the answer we are getting in fraction. So in order to simplify it, let's take the LCM of the denominator. So it will be 32 for all. Denominator will become 32 for all three. Now what will be the numerator? So 2 into 16 is 32. So here we have 16. Then here we have 1 and here we have 2. Okay. So we'll consider the ratio of the numerator as the final ratio. That means 16 is to 1 is to 2. So this is the ratio of the volumes of hydrogen, oxygen and methane. That means option number C will be the correct answer. Question number 49 is from the chapter solid state, and the question is, if A is the length of the side of a cube, the distance between the body centered atom and one corner atom in the cube will be. Okay. So suppose this is the cube. This is your cube. Now we have to find the distance between the body centered atom, that means an atom that is present here at the body center, and one corner atom, that means here. Okay. So this distance, as you can see, it is half of the diagonal. Okay. Distance is half of diagonal. We know that the diagonal of a cube is equal to root 3a. So half of the diagonal will be equal to root 3a by 2. Okay. That means option D will be the correct answer. Question number 50 is from the chapter Surface Chemistry, and the question is, which property of colloids is not dependent on the charge on colloidal particles? Option A, coagulation, option B, electrophoresis, option C, electroosmosis, and option D, Tyndall effect. Okay. So the answer will be Tyndall effect, because Tyndall effect is an optical phenomena. Okay. It is an optical phenomena, and it is due to the scattering of light, due to the scattering of light and not due to charge. Whereas in other options, charges are involved. Okay, so the correct answer will be option number D. Question number 51 is from the chapter Equilibrium, and the question is, which of the following salts will give highest pH in water? Okay, so let's see. The first one is KCl, that is potassium chloride. We know that a salt is made from an acid and a base. So if we hydrolyze KCl, what do we get? We'll get KOH. So this is the base and HCl is the acid here. Okay, that means it is made from a strong base and a strong acid. Okay. Now, whenever a salt is made from strong base and strong acid, then the pH of the salt is equal to 7. Okay. Then the next one is NaCl. So if we hydrolyze NaCl, what is the base we get? It is NaOH and the acid is HCl. Okay. So NaOH is a strong base again and HCl is also a strong acid. So this time also we have a strong base plus strong acid. That means again the pH will be 7. Then the third one is Na2CO3. So what is the base and acid in this case? On hydrolyzing it, we'll get NaOH plus H2CO3. So NaOH, as we have seen, it is a strong base, but H2CO3 is a weak acid. Okay, it is not a strong acid. That means in this case, the basic character will be more. That means the pH will be more than 7. Because for base the pH is more than 7. And in the last one, CuSO4, the base is CuOH2 and acid is H2SO4. So this time the base is weak, and the acid is strong. Okay, strong acid. So which character will be more effective? Acidic character. So here the pH will be less than 7. So we have to tell which will have the highest pH. So as it is clear from the given data that third one has the highest pH. This is the only case where the pH is more than 7. So option C will be the correct answer. Question number 52 is from the chapter Solutions, and the question is, of the following 0.10 molar aqueous solutions, which one will exhibit the largest freezing point depression? So we know that delta TF, that is freezing point, is equal to Van Hoff factor I into Kf, that is molar freezing point depression constant, into small m, that is molality. Okay. Now we know that for a particular solvent, the value of Kf is constant. So here the solvent is same in all the given options, that is water, because it is mentioned in the question that these are aqueous solutions. Aqueous solution means solvent is water. So since the solvent is same, so the value of Kf will also be constant. And molality is also same. So this value will also be constant. It is given in the question. The molality is 0.10 molar, right? So delta TF will depend only on the Van Hoff factor small I. Okay, more the Van Hoff factor, more will be the value of delta TF, that is freezing point depression. So let's see which one will have the highest value of Van Hoff factor. The first one is KCl. If it is dissociated, what do we get? We'll get K plus and Cl minus. So Van Hoff factor is equal to number of moles of the product. So how many moles? 1 and 2. 1 for K plus and 1 for Cl minus 2, and divided by number of moles of the reactant, only 1. So the Van Hoff factor in this case is 2. Then the second is C6H12O6. This is an organic compound, right? This is an organic compound. So there is no dissociation in this case, right? So the Van Hoff factor will be, sorry, this is small I, right? Van Hoff factor is written as small I, so that is equal to 1, because the number of moles of the product will also be 1 and that of the reactant will also be 1. Then the third one is Al2SO4 3. Now if it is dissociated, what do we get? We get 2Al3 plus 3SO4 2 minus. So what is the number of moles of the product? 2 plus 3, that is 5, and that of the reactant is only 1. So 5 by 1, that is 5. This is the Van Hoff factor in this case. And the last one is K2SO4. So if it is dissociated, what do we get? We get 2K plus SO4 2 minus. So the Van Hoff factor will be equal to number of moles of product, that is 2 plus 1, that is 3, upon number of moles of the reactant, that is 1. So in this case Van Hoff factor is 3. So you can compare the Van Hoff factor in all the 4 cases. You can see in the third case, that means in Al2SO4 3, the Van 't Hoff factor is maximum. So the value of delta TF will also be maximum in this case. So the correct answer will be option number C. Question number 53 is from some basic concepts of chemistry, and the question is, when 22.4 liters of H2 gas is mixed with 11.2 liters of Cl2 gas, each at STP, the moles of HCl gas formed is equal to. Okay, so first of all we should know that at standard temperature and pressure, that is STP, the volume of 1 mole of a gas is equal to 22.4 liters. Now we have 22.4 liters of H2 gas. That means we have 1 mole of H2 gas, whereas we have only 11.2 liters of Cl2 gas, that is half of 22.4. So we have only 0.5 moles of Cl2 gas. Okay, so this is given in the question. Now we know that generally what happens when H2 reacts with Cl2, it gives 2HCl. That means when 1 mole of H2 reacts with 1 mole of Cl2, it gives 2 moles of HCl. This is the general case. But according to the question, we have 1 mole of H2 and only 0.5 mole of Cl2. Okay, not 1 mole of Cl2. So in this case, what will happen? The amount of chlorine or the number of moles of chlorine is less than required. So it will act as the limiting reagent. So instead of the reaction of 1 mole of H2 and 1 mole of chlorine, Cl2, only the reaction of only 0.5 moles of H2 and 0.5 moles of Cl2 will take place. Okay, 0.5 moles of H2 and 0.5 moles of Cl2 will take place. So as compared to the main reaction, the general reaction, only half the number of moles of H2 and Cl2 are taking part in the reaction. That means only half of the number of moles of HCl will be formed. That means instead of 2 moles of HCl, only 1 mole of HCl will be formed. Okay, HCl is formed instead of 2 moles. So option A, 1 mole of HCl gas will be the correct answer. Question number 54 is from the chapter Electrochemistry, and the question is, when 0.1 mole of MnO4 2- is oxidized, the quantity of electricity required to completely oxidize MnO4 2- to MnO4- is. Okay, so if we write the reaction for this oxidation, we have MnO4 2-. When it oxidizes, it will give MnO4- plus 1 electron. Okay, so basically MnO4 2- will lose 1 electron to form MnO4-, isn't it? So 1 mole of MnO4 2- is giving 1 mole of MnO4- and 1 electron. Now 1 electron corresponds to 1 Faraday electricity. 1 Faraday electricity. And 1 Faraday electricity means 96500 Coulomb. Okay, so this much charge. That means for the oxidation of 1 mole of MnO4 2-, let's write it down here. For the oxidation of 1 mole of MnO4 2-, 96500 Coulomb charge is required. Okay, required. And in the question, it is given that 0.1 mole of MnO4 2- is oxidized. Okay, so for the oxidation of 0.1 mole of MnO4 2-, 0.1 into 96500 Coulomb will be required. Okay, that means 9650 Coulomb charge or electricity is required. So let's see, 9650 Coulomb is given in option number C. So option C will be the correct answer. Question number 55 is from the chapter Equilibrium, and the question is, using the Gibbs change delta G naught equals to 63.3 kilojoule For the following reaction, this is the reaction, the Ksp of Ag2CO3 in water at 25 degrees Celsius is, the value of R is given. Okay. So we know that at equilibrium, the value of delta G naught is equal to minus 2.303 RT log K equilibrium, right? And K equilibrium here means Ksp of Ag2CO3. So log Ksp will be equal to delta G naught divided by minus 2.303 into RT. Okay. So let's put the values here. Delta G naught is given as 63.3 kilojoule. So we can write it as 63.3 into 1000 joules divided by minus 2.303 into the value of R is given in the question 8.314 and T, that is temperature, is given as 25 degrees Celsius. So in Kelvin it will be 273 plus 25, that means 298 Kelvin. Okay, and on solving this you will get minus 11.09. Okay, so this is the value of log Ksp. So Ksp will be equal to anti-log of minus 11.09, that is 10 to the power minus 11.9. Okay, now if we have to solve it, we can simplify it. Okay, we can write it as 10 to the power minus 12 into 10 to the power plus 0.91. Okay, if you solve this you will get 10 to the power minus 11.9. So we have simplified this. Now what will be the value of 10 to the power 0.91? It will be somewhere between 8 and 9. So we can write 8 approximate value into, let's write 10 to the power minus 12 as it is. So 10 to the power minus 12. So the correct answer will be option number B, 8 into 10 to the power minus 12. Question number 56 is from the chapter Electrochemistry, and the question is, the weight of silver displaced by a quantity of electricity which displaces 5600 ml of oxygen at STP will be. So we have a certain quantity of electricity which displaces 5600 ml of oxygen, and the same quantity of electricity also displaces some amount of silver. So we have to find the weight of silver that is displaced. Now we know that at standard temperature and pressure, that is STP, 1 mole of a gas occupies how much volume? 22.4 liters volume. Okay, 22.4 liters, that is 22,400 milliliters volume. Okay, it means that 22,400 ml of oxygen corresponds to 1 mole of oxygen at standard temperature and pressure. So 5600 ml of oxygen will correspond to 1 by 22,400 into 5600 moles. And on solving this we'll get 1 by 4 moles. That means 1 by 4 moles of oxygen is displaced by the electricity. So what is the weight of oxygen? Weight of oxygen displaced. So weight is equal to number of moles into the molar mass. Okay, molar mass. So number of moles displaced is 1 by 4 and molar mass of oxygen is 32. So it is 8. That means 8 grams of oxygen is displaced. Okay, so we have to find the weight of silver that will be displaced. So for that we'll use Faraday's second law of electrolysis. Faraday's second law of electrolysis. Now, according to this law, when the same quantity of electricity is passed through the solution of different electrolytes, then the mass of substance produced at the electrodes is directly proportional to the equivalent weight. Okay, so weight or mass of substance produced or displaced is proportional to the equivalent weight of the substance. That means the ratio of weight and equivalent weight is constant. So using this concept we can say that the weight of silver upon the equivalent weight of silver is equal to weight of oxygen upon equivalent weight of oxygen. So let's put the values now. We don't know what is the weight of silver, that we have to find out. So let's write it as W only. And equivalent weight of silver. What is equivalent weight of silver? We know that equivalent weight is equal to atomic weight divided by valency. Okay, so atomic weight of silver is 108 and valency is 1. That means equivalent weight will be 108. Okay, similarly for oxygen, atomic weight is 16 and valency is 2. So the equivalent weight of oxygen will be 8. Okay, so let's put the values. Equivalent weight of silver is 108 and this side weight of oxygen displaced, we have found out it is 8 grams and equivalent weight of oxygen is also 8. So this side we have 1. So from here we can say that the weight of silver displaced W is equal to 108 grams. So let's see the options now. In option number D, 108 grams is given. So option D will be the correct answer. Question number 57 is from the chapter Equilibrium, and the question is, which of the following statements is correct for the spontaneous adsorption of a gas? So we know the equation delta G equals to delta H minus T delta S, right? Delta H means enthalpy change. T is temperature and delta S means entropy change. Okay, entropy change. And entropy represents randomness of the particles, randomness of gas particles. Now here there is spontaneous adsorption of a gas. So we know that for a spontaneous reaction, delta G is always negative. Okay, and adsorption means the gas molecules will get adsorbed on a surface, so their mobility will decrease. Their mobility will decrease, and when mobility decreases, it means the randomness of gas particles will decrease. Randomness decreases, and we know that randomness is represented by the entropy, so it means that entropy will also decrease. So delta S will be negative. Okay. So in this reaction, we know that delta S is negative because there is decrease in randomness. Okay, so delta S is negative. So this equation delta G becomes delta H plus T delta S, because delta S is negative. So this negative and negative will become positive. Now we have to make delta G negative. So for that, delta H must be highly negative, then only delta G will become negative. If delta H will be positive, then positive plus positive will be positive. Okay, but delta G should be negative, so for that delta H must be highly negative. So what is the conclusion? Delta G is negative, delta H is also negative, and delta S is also negative. Okay, all are negative. That means let's read the options now. First option is delta S is negative and therefore delta H should be highly positive. So it is incorrect. Delta H should not be highly positive. Then second statement says delta S is negative and therefore delta H should be highly negative. Yes, this is correct. Third statement says delta S is positive. So this is incorrect because delta S is negative due to decrease in randomness. And the last option says delta S is positive. Again, this is incorrect. Delta S is negative. So the only correct statement is second one. Option B will be the correct answer. Question number 58 is from the chapter Equilibrium, and the question is, for the reversible reaction, this is the reaction, the equilibrium shifts in forward direction. So we have to choose the option which will be responsible for the movement of equilibrium in the forward direction, that means towards the product side. Okay, towards the product side. Now let's come to the options. The first option is by increasing the concentration of ammonia gas. So we know that according to Lee-Chartier's principle, whenever a dynamic equilibrium is disturbed due to change in condition, then the system tries to counteract that change or oppose that change to bring back the equilibrium. Okay, so here in this option, the concentration of ammonia gas is being increased. That means on the product side, ammonia gas is being increased. So the system, according to Lee-Chartier's principle, will try to oppose this change. That means system will try to decrease the concentration of ammonia. And when the concentration of ammonia will decrease, then the concentration of nitrogen and hydrogen on the reactant side will increase. Okay, so we can see that the equilibrium is moving towards the reactant side. Okay, reaction is moving towards the reactant side. The concentration of reactant will start increasing and that of product will start decreasing. Okay, so this will move the equilibrium in the backward direction, not in the forward direction. That means this is not the correct option. Now let's come to the second option, by decreasing the pressure. So for pressure and temperature we have some rules. So let's write down here pressure and this side temperature. So whenever the pressure is increased, when the pressure is increased, then what happens? The reaction will move towards the direction where there are fewer number of moles. And if the pressure is decreased, then what will happen? The reaction will move in the direction where there are more number of moles. And for temperature, the rule is just opposite. That means if the temperature is increased, then the reaction will move in the direction where there are more number of moles. And if the temperature is decreased, in that case, the reaction will move in the direction where there are fewer number of moles. So if you look at the reaction mentioned in this question, we can see that on the reactant side we have 1 mole of nitrogen and 3 moles of hydrogen. So total 4 moles are present on the reactant side, and on the product side we have only 2 moles of ammonia. So on the product side we have 2 moles, fewer moles. Okay, so in this option, second option, it is mentioned by decreasing the pressure. So if we decrease the pressure, that means this rule, if the pressure is decreased, then the reaction will move towards more number of moles, right? More number of moles means towards the reactant side, because on the reactant side we have 4 moles and on the product side only 2 moles. So more number of moles, that means towards the reactant side, that means this will be a backward reaction. Okay, so the second option is also incorrect because this will move the equilibrium in the backward direction. Then the third option is by decreasing the concentration of nitrogen and hydrogen. So if we decrease the concentration of nitrogen and hydrogen, then the system will try to increase the concentration of nitrogen and hydrogen, right? It will just oppose the change. So the concentration of nitrogen and hydrogen will increase. That means the reactant side concentration will increase. That means again this is a backward direction, because for forward direction the concentration should increase on the product side, not towards the reactant side. So this is also incorrect. Now the last option is by increasing the pressure and decreasing the temperature. So see, in pressure we have seen that when the pressure is increased, then it will move towards fewer number of moles. Fewer number of moles are present on the product side, right? Only 2 moles. So this is the sign of forward direction. Then decreasing the temperature. So if the temperature is decreased, then again it will move towards the fewer number of moles. That means on the product side. Okay. So in both the cases, the reaction is moving towards the product side. That means forward reaction is favored in this case. Okay. Forward reaction. That means option D will be the correct answer. Question number 59 is from the chapter thermodynamics, and the question is, for the reaction, this reaction is given delta U equals to 2.1 kilocalorie, delta S equals to 20 calorie per Kelvin at 300 Kelvin. That means temperature is 300 Kelvin. Hence delta G is. So in this question we'll use two different formula. First we'll use the formula delta H equals to delta U plus delta NG RT. So using this equation we'll find the value of delta H, that is enthalpy change. Okay, so let's put the values. Delta U, that means change in internal energy, it is given in the question 2.1 kilocalorie. So it can be written as 2.1 into 1000 calorie. Okay, plus delta NGRT. So delta Ng means change in number of gaseous moles. Okay, change in number of gaseous moles. That means number of moles on the product side or final number of moles minus number of moles on the reactant side, that is initial number of moles. Okay, and we are talking about the gaseous moles. So on the product side we have 2 moles of XO2. So 2 minus the number of gaseous moles on the reactant side is 0, because here the reactant is liquid, not gas. Okay, so delta N is equal to 2 here. So 2 into the value of R, that is gas constant, is 1.98 in terms of calorie. So we can write it as 2, and T is the temperature, so that is given as 300 Kelvin. Okay, and if we solve this we'll get 2100 this side and this side 1200. So 3300 calorie is the value of delta H. Okay, enthalpy change is 3300 calorie. Now we have to find the value of delta G. So for that we'll use another equation, that is delta G equals to delta H minus T delta S. Okay, so delta H we have just calculated 3300 calorie minus T is the temperature, that is 300 Kelvin, right? So 300 Kelvin into delta S, entropy change. This value is given as 20 calorie per Kelvin in the question. So 20. Okay. So 3300 minus 6000. So if we subtract this, it will be in minus, right? Minus 2700, and the unit will be calorie. So here in the options, kilocalorie is given. So we can write it as minus 2.7 kilocalorie. Okay, by dividing it by 1000. So minus 2.7 kilocalorie will be the correct answer. That means option B will be the correct answer. Question number 60 is again from the chapter thermodynamics, and the question is, for a given exothermic reaction, Kp and Kp dash are the equilibrium constants at temperatures T1 and T2 respectively. Assuming that heat of reaction is constant in temperature range between T1 and T2, it is readily observed that. So it is given that at temperature T1 the equilibrium constant is Kp, whereas at temperature T2 the equilibrium constant is Kp dash. Also it is given that the reaction is exothermic, and we know that for exothermic reaction the value of delta H, that is enthalpy change, is negative, whereas the value of delta T, that is temperature change, is positive, right? Now delta T is positive, it means T2 minus T1 is positive. So from here we can say that T2 must be greater than T1, then only T2 minus T1 will be positive, right? And since T2 is greater than T1, therefore we can also say that 1 by T2 will be less than 1 by T1. Okay, so these things you have to keep in mind. Now here we have to find the relation between Kp and Kp dash. So we can use the formula log Kp dash upon Kp equals to delta H upon 2.303 R 1 by T1 minus 1 by T2. Okay, this is the formula that you should remember. So here we have seen that this is exothermic reaction. So T2 is greater than T1. That means 1 by T2 is less than 1 by T1. Okay, so in this under bracket you can see that 1 by T2 is less than 1 by T1. That means this whole value under bracket is positive. Okay, why? Because 1 by T2 is less than 1 by T1, right? So this is positive, but for exothermic reaction the value of delta H is negative. So negative into positive means negative. This overall value will come out to be negative, right? So log Kp dash upon Kp is negative. So we can say that log Kp will be greater than log Kp dash. Okay. So Kp will be more than Kp dash. So this is the relation between Kp and Kp dash. Okay. So Kp is more than Kp dash. That is given in the first option. So option A will be the correct answer. Question number 61 is from the chapter Classification of Elements and Periodicity in Properties, and the question is, which of the following orders of ionic radii is correctly represented? So if you look at the options, you'll see that all the elements mentioned in an option are isoelectronic species. Okay, Na plus ion, chloride ion and O2 minus ion. All these are isoelectronic, that means containing same number of electrons. And we know that for isoelectronic species, isoelectronic species, ionic radii is inversely proportional to the atomic number. Okay, so let's check. In the first option we have Na plus, then F minus and O2 minus. What is the atomic number of sodium? Atomic number of sodium is 11. Okay, atomic number of fluorine is 9 and atomic number of oxygen is 8. Okay, we are talking about the atomic numbers. So what should be the correct order? The maximum atomic number, that means Na plus, then F minus and then O2 minus. Okay, this is the sequence of atomic number. So what will be the sequence of ionic radii? Ionic radii, it is inversely proportional, so the sequence will be just the reverse. That means O2 minus will have the maximum ionic radii, then F minus and then Na plus. Okay, but in this option this sequence is not given, so this is incorrect sequence. Okay, the sequence that is given here is the sequence of atomic number, not ionic radii. Now let's come to the second option. Again this is incorrect because same elements are mentioned here also and same species are there. That means here also the correct order will be O2 minus, then F minus and then Na plus. So both of them are incorrect. Now let's come to the third one. So in this option we have aluminium, Al3 plus ion, then Mg2 plus and then N3 minus. What is the atomic number of aluminium? So the atomic number of aluminium is 13. Then the atomic number of magnesium is 12 and the atomic number of nitrogen is 11. So if we arrange it in decreasing order in atomic number, so the decreasing order of atomic number will be aluminium, then magnesium and then nitrogen. Okay, this is the decreasing order of atomic number. So what will be the correct order of ionic radii? Just the reverse of this, that means N3 minus, then Mg2 plus and then Al3 plus. So you can see that this sequence is not mentioned in this option, so this is also incorrect. Again, this is the correct order of atomic number, not ionic radii. So all of them are incorrect. That means option D, none of the above will be the correct answer. Question number 62 is from the chapter Some Basic Concepts of Chemistry, and the question is 1 grams of magnesium is burnt with 0.56 grams oxygen in a closed vessel. Which reactant is left in excess and how much? Atomic weight of magnesium is given as 24 and that of oxygen is 16. So let's write down the equation for this reaction. We have magnesium. It reacts with oxygen to form magnesium oxide. If we balance this equation, we'll get 2 this side and 2 this side. Now, what will be the atomic weight of magnesium? 24. It is given in the question. So, the total mass of magnesium according to this equation will be 2 into 24, that is 48 grams. Similarly, the mass of oxygen here is 2 into the atomic mass of oxygen 16. So, 32 grams of oxygen is there. So, from here we can say that to burn 48 grams of magnesium, 32 grams of oxygen is required. So to burn 1 gram of magnesium, how much oxygen is required? 32 divided by 48, that is approximately equal to 0.67 grams, right? To burn 1 gram of magnesium, 0.67 grams of oxygen is required. But according to the question, in order to burn 1 gram of magnesium, how much oxygen is used? 0.56 grams of oxygen is used. But we need at least 0.67 grams of oxygen. That means the amount of oxygen is less than that required. Okay, it is less than that required to burn the magnesium. That means oxygen will act as the limiting reagent. Act as limiting reagent, and it will get consumed completely. Get consumed completely. That means oxygen is not left in excess. It will get completely consumed during the reaction. Instead, magnesium will be left in excess. Okay, because insufficient oxygen was available for burning of 1 grams of magnesium. So some amount of magnesium will be left. Okay, so from here we can conclude that magnesium is left in excess. So one part of the question is answered here, okay, because the question asks which reactant is left in excess. So the answer is magnesium. Now how much? So let's see. We know that according to the above reaction, 32 grams of oxygen burns how much magnesium? 48 grams of magnesium. But how much oxygen is available we have? According to the question, 0.56 grams of oxygen. So 0.56 grams of oxygen will burn 48 divided by 32 into 0.56 grams of magnesium. So on solving this, we'll get 0.84 grams. So this much magnesium will be burnt. Okay, this much magnesium is burnt. So how much left? Magnesium left is 1 gram minus 0.84 grams. So on solving this, we'll get 0.16 grams. Okay, so 0.16 grams of magnesium will be left in excess. So let's see the options. In the first option, yes, first option only is the correct one. Magnesium is left in excess and 0.16 grams of magnesium. So option A is the correct answer. Question number 63 is from the chapter redox reaction, and the question is the pair of compounds that can exist together is. So here we have to remember one thing, that if one of the compounds is oxidizing and the other is reducing, then these two cannot exist together because one will eventually reduce the other. Okay. Now let's come to the options. In the first one we have FeCl3. In this the oxidation state of Fe is +3 and that of Sn is +2. So in this case, what will happen? Fe3 plus will get reduced, okay? Because it can also show +2 oxidation state. So it can get reduced from +3 to +2 oxidation state, and Sn +2 will get oxidized. It cannot get reduced because Sn2 plus is the minimum oxidation state. Okay, it cannot reduce further. It can only get oxidized. So one will get reduced and the other will get oxidized. That means these two will not exist together. Not exist together. Now let's come to the second option. We have Hg. So the oxidation state of Hg here is +2 and that of Sn is also +2. Now we know that Hg can also show +1 oxidation state. So Hg2 plus will get reduced to +1 oxidation state. Okay, and Sn2 plus will get oxidized. So these two will also not exist together. Now let's come to the third one. Here the oxidation state of Fe is +2 and that of Sn is also +2. Now we know that for Fe +2 is the minimum oxidation state and same for Sn. That means both cannot reduce further. So Fe 2 plus and Sn 2 plus both will only get oxidized, can get oxidized only. These cannot get reduced because these plus 2 is the minimum oxidation state for both of them. So they can exist together. They can exist together because no one is reducing the other. And in the third one also, the oxidation state of Fe is plus 3. So it can get reduced. Okay, it can get reduced to plus 2 oxidation state. And the oxidation state of iodine is minus 1, so it can get oxidized. It can get oxidized. So again, one will oxidize, one will reduce the other, so these will not exist together. Not exist together. Only the third one is the correct answer. Okay, option number C. Question number 64 is from the chapter Classification of Elements, and the question is Be2 plus is isoelectronic with which of the following ions? So Be2 plus, what is the atomic number of beryllium? 4. So the number of electrons in beryllium is 4 and there is plus 2 charge. So the total number of electrons will be 4 minus 2. That means 2 electrons have been removed. So 4 minus 2 is equal to 2. So total number of electrons in Be2 plus ion is 2. Okay. So let's check which one of the given options has 2 electrons. So in the first option we have H plus. So hydrogen has only one electron and one plus charge, that means minus 1. So no electron is available in H plus ion. Okay. In the second option we have lithium plus ion. So lithium atom has 3 electrons and one plus charge means one is removed. So 2. So yes, this also contains 2 electrons, same as Be2 plus ion. Let's check other two. Sodium ion. So the atomic number of sodium is 11. That means the number of electrons is 11. And plus 1 charge, that means 1 electron removed. So the number of electrons left is 10. Then the last one is magnesium. So the number of electrons in magnesium atom is 12. And plus 2 charge, that means 2 electrons have been removed. So 12 minus 2 equals to 10. So C and D have 10 electrons each. Only lithium plus ion has 2 electrons, same as Be2 plus ion. That means option B will be the correct answer. Question number 65 is from the chapter Chemical Bonding and Molecular Structure, and the question is which of the following molecules has the maximum dipole moment? Okay, so what is the direction of dipole moment? It is always from less electronegative atom towards the more electronegative atom. Okay, less electronegative atom towards more electronegative atom. Also, the direction is from an atom towards the lone pair. Okay, when lone pair is present, then it is towards the lone pair. So this is the direction of the dipole moment that we have to keep in mind. Now let's check one by one. In the first option we have carbon dioxide. So if we draw the structure of carbon dioxide, this is carbon. Here we have double bond oxygen, double bond oxygen. Now which is less electronegative? Carbon is less electronegative and oxygen is more electronegative. So the direction will be from carbon towards the oxygen in both the directions. Okay. So as you can see that the bond is same, but the direction of the dipole moment is different. So magnitude will be same, but the direction will be opposite. So the overall dipole moment will be 0 because these two will cancel out the effect of each other. Now let's come to the second option, that is methane. So if we draw the structure of methane, this is carbon, this is hydrogen, this is one hydrogen, then another hydrogen, and then another one. Now here the effect of these three bonds, the dipole moment, the combined dipole moment of these three bonds will be in the upward direction. That means from hydrogen to the carbon. Okay, because carbon is more electronegative as compared to hydrogen. And if we talk about the upper carbon hydrogen bond, so here the direction will be from hydrogen to carbon. That means in the downward direction. So these two will also cancel out each other's effect and the overall dipole moment will come out to be 0. Now we come to the third one, that is ammonia, NH3. So let's draw the structure of ammonia. This is nitrogen, this is hydrogen. So we have 3 hydrogen here and one lone pair of electron on the nitrogen. So the direction will be from hydrogen to nitrogen, right? Less electronegative towards the more electronegative atom. So the combined dipole moment due to these 3 bonds will be in the upward direction, that means towards the nitrogen. And also we know that the direction is from an atom to the lone pair. So in the upward direction it is from nitrogen towards the lone pair. So you can see that these two are in the same direction. So these two will, the effect of these two will be added up. Okay. So it will be a very high value of dipole moment. Okay. High dipole moment in the upward direction. And the last option is NF3, nitrogen trifluoride. So this is nitrogen. We have 3 fluorine atoms, but we know that fluorine atoms are more electronegative than nitrogen. So unlike the ammonia, here the direction of these 3 will be in the downward direction from nitrogen to fluorine, whereas the lone pair that is present on the nitrogen, here the direction is from nitrogen towards the lone pair. So this time it is opposite direction. Okay, in ammonia the direction was same, in nitrogen trifluoride the direction is opposite. So the overall effect will be the difference between the two. So it will be less dipole moment as compared to the ammonia. So here we have to find the maximum dipole moment. So ammonia will have the maximum dipole moment. Okay. So option C will be the correct answer. Question number 66 is from the chapter Chemical Bonding and Molecular Structure. And the question is, which one of the following species has plain triangular shape? So for plain triangular shape or trigonal planar shape, there should be an sp2 hybridization without any lone pair of electrons. Okay, so no lone pair of electrons should be there. Now let's check one by one. First option is N3 minus. So if you draw the structure of N3 minus, it will be N triple bond N and this side single bond N, or it can be like this, nitrogen double bond N and double bond N. Okay, plus charge and here minus charge. So these are the structures of N3 minus. The hybridization in this case is sp and the shape is linear. So definitely this is not trigonal planar. So this is not the correct answer. Let's check another one. The second option is NO3 minus. So this is nitrogen. This is double bond O and single bond O. So here the hybridization is sp2 hybridization and there is no lone pair of electron. Okay, no lone pair of electron on the central atom, that is nitrogen. So the shape is trigonal planar. Trigonal planar, or we can say plain triangular shape as it is asked in the question. So this is the correct answer, but let's check other options as well. Third one is NO2 minus. So this is nitrogen, this is double bond O, this is single bond O, this is NO2 minus. So here also hybridization is sp2, but in this case the nitrogen has a one lone pair of electron. Okay, so due to the presence of lone pair of electron, there will be repulsion and it will become V-shaped, V-shaped or bent shaped. Okay, so this is not trigonal planar. Now we come to the last option, that is CO2, carbon dioxide. So this is very simple, carbon double bond O, similar to the first one. So the hybridization in this case is sp and the shape is linear. Okay, so the only option where the shape is plain triangular, it will be the second one, NO3 minus. So option B is the correct answer. Question number 67 is from the P block elements and the question is, acidity of diprotic acids in aqueous solutions increases in the order. So what is acidity? It is basically a tendency to release H plus ions. Okay, it is the measure of tendency to release H plus ions. Now if you look at the options, you can see that 3 elements are mentioned in all the options: sulfur, selenium and tellurium. Okay, and these are group 16 elements. Group 16 elements. Sulfur, then selenium, and then tellurium. This is the sequence of elements on moving down the group. Okay. Now what happens on moving down the group? Moving down the group, the size of the atom increases. Okay. That means atomic size increases. When the size of the atom increases, bond length also increases. Bond length also increases, and as the length of the bond increases, its strength decreases. Okay, so it leads to weaker bonds as we move down the group. Okay, so if we compare the bond strength of H2S, H2SE and H2Te, so from sulfur to tellurium, the size of the atom is increasing, bond length is increasing, so the bond is becoming weaker. So this will be the sequence of acidity, because as the bond will become weaker, the hydrogen ion releasing capacity will increase. Releasing capacity increases, okay, because the bond is able to break easily, so H plus ion will be released very easily. Okay, so this is the correct sequence of acidity. That means option A will be the correct answer. Question number 68 is from the chapter redox reaction, and the question is role of hydrogen peroxide in the above reactions is respectively. So two reactions are given here, and we have to identify the role of hydrogen peroxide, whether it is acting as an oxidizing agent or a reducing agent. So let's write down the reaction. First reaction is H2O2 plus ozone, that is O3, gives water plus oxygen. So here hydrogen peroxide is getting converted into oxygen and ozone is getting converted into water. Okay. So what is the oxidation state of oxygen in hydrogen peroxide? In hydrogen peroxide, that is H2O2, the oxidation state of oxygen is -1. And when it is converted into oxygen, pure oxygen, then its oxidation state becomes 0, because we know that in pure state the oxidation number or the oxidation state is 0. Okay, so for H2O2 the oxidation state has been increased from -1 to 0. Okay, it is increased, and when the oxidation state is increased, it means it has undergone oxidation. So hydrogen peroxide has undergone oxidation, and when it itself undergoes oxidation, it means it acts as the reducing agent for others. Okay, acts as a reducing agent. So the role of hydrogen peroxide is reducing in the first reaction. Now let's come to the second reaction. It is H2O2 plus Ag2O gives 2Ag plus H2O plus O2. Okay, so here merely looking at the silver oxide reaction, we can say whether hydrogen peroxide is acting as reducing or oxidizing agent. So here we can see that in silver oxide the oxidation state of silver is +1, and then it is converted into pure silver where its oxidation state becomes 0. So for silver oxide the oxidation state is decreased. It is decreased from +1 to 0. Right? That means silver oxide has undergone reduction. Undergone reduction. And who is responsible for the reduction of silver oxide into silver? Hydrogen peroxide. Okay. So hydrogen peroxide again is acting as the reducing agent. Okay. It acts as a reducing agent. So in the first reaction, hydrogen peroxide was reducing ozone into water, and in the second reaction, it is reducing silver oxide into silver. So in both the reactions, hydrogen peroxide is acting as the reducing agent. That means option C will be the correct answer, reducing in A and B. Question number 69 is from the chapter Chemistry in Everyday Life, and the question is artificial sweetener which is stable under cold conditions only is. Options are saccharine, sucralose, aspartame and allicin. So the correct answer is option C, that is aspartame. Okay, this is a fact that aspartame is stable only at the cold conditions and it is unstable at the cooking temperature. Okay, unstable at high temperatures or more specifically cooking temperature. And this is the reason why it is used only in the cold foods. Used only in cold foods. For example, ice creams. Example, ice cream. Whereas all the other options, that means saccharine, sucralose and allicin, these are stable to heat. So according to the question, the correct answer will be option number C. Question number 70 is from the chapter Redox Reaction, and the question is in acidic medium H2O2 changes dichromate ion to CrO5 which has two oxygen-oxygen bonds. Oxidation state of chromium in CrO5 is. So we have to determine the oxidation state of chromium in CrO5. Now we know that CrO5 has a butterfly structure. That means we have a central chromium atom, then four oxygen atoms like this. These four oxygen atoms form peroxide bond. Okay, and then we have one chromium oxygen double bond. So we know that usually the oxygen has -2 oxidation state. So this carbon oxygen double bond, this oxygen will have -2 oxidation state, okay, because this is a general oxygen. But other four oxygens are forming peroxide bond. So we know that the oxygens of peroxide bond have -1 oxidation state. So these four oxygens will have the oxidation state -1. Okay. Now we know that the sum of all the oxidation states will be 0. So suppose the oxidation state of chromium is X. So X -1, -1, -1, -1 and -2. This will be equal to 0. So X -6 will be equal to 0. So from here we can say that X is equal to +6. That means the oxidation state of chromium in CrO5 will be +6. So option C will be the correct answer. Question number 71 is from the chapter D and F block elements, and the question is the reaction of aqueous potassium permanganate with H2O2 in acidic conditions gives. Okay, so we know that potassium permanganate is a strong oxidizing agent, right? Strong oxidizing agent, especially in the acidic medium. Okay, so its oxidizing character is stronger in acidic condition. Now when it oxidizes others, therefore we can say that itself gets reduced. Okay, itself gets reduced. So when it will react with H2O2, that is hydrogen peroxide, it will get reduced to Mn2 plus ion. Reduced to Mn2 plus ion. And definitely, since potassium permanganate is oxidizing in character, so it will oxidize the hydrogen peroxide. So it will get oxidized to form oxygen and water. Therefore, what will be the resulting products? Mn2 plus ion and oxygen. That means option B should be the correct answer. Okay, and let's see the balanced equation for this. Balanced equation. So we have 2KMnO4 potassium permanganate plus hydrogen peroxide plus 3H2SO4 sulfuric acid, and this reaction will give K2SO4 plus 2MnSO4 plus 5O2 plus 8 molecules of water. Okay, so here the oxidation state of manganese is +2. So this is Mn2 plus ion and we are getting oxygen as well. Therefore option B is the correct answer. Question number 72 is from the chapter Coordination Compound, and the question is among the following complexes the one which shows zero crystal field stabilization energy. Okay, so let's check one by one. All the options here are octahedral complexes, and we know that for octahedral complexes, d orbitals split into two energy levels, the lower energy level known as T2G level and the higher energy level known as EG level. Okay, now out of 5 d orbitals, 3 orbitals are present in the lower T2G level and the rest 2 orbitals are present in higher energy EG level. Okay, this is the center point. Now, the energy gap between the higher energy level and the center point is 0.6 delta naught, and the energy gap between the lower energy level and the center point is minus 0.4 delta naught. Okay, so using these values we'll find the crystal field stabilization energy for each of the given options. In the first option we have manganese ion, Mn3 plus ion. Okay, and the electronic configuration of Mn3 plus ion is 3d4. That means we have 4 electrons here. So when d orbitals will split, 3 orbitals in the lower level and 2 orbitals in the upper higher level. Okay, so 4 electrons have to be filled in these levels, and the filling of electron will start from the lower level. Okay, so 1, 2, 3, and then it will move to the higher level 4. Okay, now crystal field stabilization energy will be equal to how many electrons in the higher energy level? 1 electron. So 1 into the energy gap was 0.6. So 1 into 0.6 delta naught plus how many electrons in the lower level? 3 electrons, and the energy gap here is minus 0.4 delta naught. Okay. So on finding the sum, we'll get 0.6 delta naught minus 1.2 delta naught, that will come out to be minus 0.6 delta naught. Okay, so here the value is not equal to 0. The question is asking which one has the value 0. So this is not equal to 0. Let's check for the second one. In second option we have Fe3 plus ion. Okay, Fe3 plus ion, the electronic configuration of Fe3 plus is 3d5. So similarly we'll fill the electrons here. We have 5 electrons this time. So 3 orbitals in the lower level, 2 orbitals in the upper level. Now 5 electrons. So 1, 2, 3, 4 and 5. Now crystal field stabilization energy will be equal to how many electrons in the upper level or higher level? 2. And the energy gap here is 0.6 delta naught plus the number of electrons in the lower level is 3 and the energy gap is 0.4 delta naught. Okay, so on solving this we'll get 2 into 0.6, that is 1.2 delta naught minus 1.2 delta naught. Okay, 3 into 0.4 is also 1.2. So here you can see that the value is equal to 0. Okay, so this time the crystal field stabilization energy is equal to 0. So this should be the correct answer, but still we'll check other options as well. Third option we have cobalt 2 plus ion. The electronic configuration for this will be 3d7. So this time we have to fill 7 electrons. Okay, so here we have 3 orbitals here, 2 orbitals here. Now 7 electrons. So 1, 2, 3, 4, 5. Then pairing will start 6, 7. Okay. Now this time how many electrons in the higher level? 2. So 2 into 0.6 delta naught plus how many electrons in the lower energy level? Total 5 electrons. Okay. So 5 into the energy gap, that is 0.4 delta naught. So 2 into 0.6 is 1.2 delta naught minus 5 into 0.4, that means 2 delta naught. So on solving this we get minus 0.8 delta naught. Again this is not equal to 0. And in the last option we have cobalt 3 plus ion. So the electronic configuration for this is 3d6. So this time we have to fill 6 electrons. Okay. So let's start filling 1, 2, 3, 4, 5 and then 6. Okay. So 2 electrons in the higher level. So 2 into 0.6 delta naught plus 4 electrons in the lower level. So 4 into minus 0.4 delta naught. So 1.2 delta naught minus 1.6 delta naught, that is equal to minus 0.4 4 delta naught. So this is also not equal to 0. So the only one in which we are getting the value 0 as the crystal field stabilization energy is the second one, that is in Fe3 plus ion. Okay. So option B will be the correct answer. Question number 73 is from the chapter D and F block elements, and the question is magnetic moment 2.83 Bohr magneton is given by which of the following ions? Atomic number is given. So we know that the magnetic moment is given by the formula mu equals to under root n plus 2, where n is the number of unpaired electrons. Okay, number of unpaired electrons. So let's check the value one by one. First one is titanium 3 plus. What is the electronic configuration of titanium 3 plus? It is 3d1. Now if we fill the electron in 3d orbitals, there are 5 orbitals. So 1, 2, 3, 4, 5. And there is only one electron. So that will be filled here, and this one electron is unpaired. So the value of n will be 1 here. And what will be the value of magnetic moment mu? Mu will be equal to under root 1 into 1 plus 2, that means under root 3, and the value of under root 3 is approximately 1.73. Okay, so this is the value of magnetic moment for titanium 3 plus ion. Now let's check the second one, nickel 2 plus ion. The electronic configuration for nickel 2 plus ion is 3d8. Now let's fill 8 electrons in 3d orbitals. So 5 orbitals are there, 1, 2, 3, 4, 5. Now 8 electrons. So 1, 2, 3, 4, 5. Now pairing will start, 6, 7, 8. So how many unpaired electrons are left? 2 electrons. So the value of n is 2 here, and the magnetic moment mu will be equal to under root 2 into 2 plus 2. That means under root 8, and the value of under root 8 is approximately 2.83 Bohr magneton. Okay, so this value is mentioned in the question, so according to that this should be the correct answer. But let's check other options as well. Chromium 3 plus ion, the third one is chromium 3 plus ion. The electronic configuration for this will be 3d3. Again we'll fill the electrons. So 1, 2, 3, 4, 5 orbitals and 3 electrons. So 1, 2, 3. Here the number of unpaired electrons is 3. So the value of magnetic moment is under root 3 into 3 plus 2. That means under root 15. Okay. So the value of under root 15 will be equal to 3.84 or 3.83 something. Okay. And the last one is Mn2 plus ion. What is the electronic configuration of Mn2 plus ion? It is 3d5. So let's fill 5 electrons in 3d orbitals. 1, 2, 3, 4, 5. Okay. So all the 5 electrons are unpaired. So the value of n will be 5 here. And magnetic moment mu will be equal to under root 5 into 5 plus 2. Okay. So here we'll get under root 35, and the value of under root 35 will be 5.89 Bohr magneton. Okay. So here the question was asked about 2.83 Bohr magneton. So that is related to the second option only, nickel 2 plus ion. So option B will be the correct answer. Question number 74 is from the chapter coordination compound, and the question is which of the following complexes is used to be an anti-cancer agent? So it is a factual question. We know that the complex that is used as an anti-cancer agent is known as diamine, dichlorido, platinum 2. Okay, platinum 2. Diamine means 2 amino groups are there, and dichlorido, that means 2 chloro groups are there attached to the central atom, that is platinum. Okay, so according to this the second option will be the correct answer. If we look at the structure, we have the central atom, that is platinum, then we have 2 amino groups on the same side and 2 chloro groups on the same side. Okay, since the similar groups are present on the same side, so this is a cis form, and it is also known as cisplatin. So it has two names, cisplatin, and it has also the name diamine dichlorido platinum 2. Okay, so option B is the correct answer. Question number 75 is from the chapter D and F block elements, and the question is reason of lanthanoid contraction is option A negligible screening effect of F orbitals, option B increasing nuclear charge, option C decreasing nuclear charge, and option D decreasing screening effect. So again, this is a factual question. We all know that the reason for lanthanoid contraction is the negligible screening effect of F orbitals. That means option A will be the correct answer. Question number 76 is from the chapter amines, and the question is in the following reaction the product A. So we have two reactants, one is diazonium salt and the other is aniline. The reaction is taking place in the acidic medium because H plus ion is involved, and as a result the product formed is a yellow dye. So we have to identify the product. Okay, so this is an example of coupling reaction. Coupling reaction of diazonium salt and aniline, and this reaction will take place at the para position, at the para position to the amino group. Okay, to the amino group in the aniline. Okay, now as a result what will be formed? An azobenzene compound will be formed. Okay, azobenzene compound is formed. So let's see the reaction now. First one is the diazonium salt, right? This is the benzene ring of the diazonium salt. Here we have nitrogen plus triple bond NCl minus. Okay, and then it is reacting with aniline. This is the benzene ring of the aniline. Here we have amino group NH2, and opposite to this amino group, that means at the para position there must be a hydrogen. Okay, so the reaction will take place between these two, and the chloride of diazonium salt and hydrogen of aniline will react to form HCl, and as a result HCl will be removed from here. Okay, so what will be formed? See, this is the benzene ring, this is nitrogen, double bond nitrogen, and this will form bond with the other benzene ring. Okay, so here we have benzene ring of the aniline and here amino group. So this is the final product that will be formed, and this will be a yellow colored dye, or this is, we can say, para azobenzene compound. Okay, para azobenzene compound. So let's see the option. In the first option we have NH here, 3 nitrogen are given, so this is incorrect. In the second one we have nitrogen nitrogen double bond, but amino group is not present at the para position, so this is also wrong. In the third one also amino group is at meta position, not para position, so wrong. And in the last one we have para position. Okay, so option D will be the correct answer. Question number 77 is again from the chapter amines, and the question is which of the following will be most stable diazonium salt? Rn2 plus X minus. So Rn2 plus X minus is the general formula of the diazonium salt, where R represents an alkyl or an aryl group. Okay, alkyl or aryl group. That means it can be an aliphatic group or an aromatic group, whereas X is a halide. Now here the common thing that we should know is that generally when it is an alkyl group then it is less stable. Okay, less stable diazonium salt, or it is unstable diazonium salt. Whereas if R is an aryl group then this is very stable diazonium salt. Okay, so in the first option we can see that R is a methyl group, so this is not stable. In second one we have R, a benzene, that means an aryl group, and this is attached to nitrogen, so yes, this will be stable. Okay, in the third one again we have an aliphatic group, okay, ethyl group, so this is unstable. In the last one we have an aryl group here, but the nitrogen is directly attached to an alkyl group. Okay, so this is also unstable. So the most stable diazonium salt will be the second one, so option B is the correct answer. Question number 78 is from the chapter biomolecules, and the question is D plus glucose reacts with hydroxylamine and yield an oxime. The structure of the oxime would be, okay. So let's see what is the structure of D plus glucose. First we have an aldehyde group, CHO, then carbon. How many total number of carbons in glucose? 6. So 1, 2, 3, 4, 5 and 6. Okay. Now after the aldehyde group, what comes? Carbon, OH on the right hand side and H on the left hand side. Okay. Then OH on the left hand side and H on the right hand side. And then again OH on the right side and H on the left side. Then at the fifth carbon, we have OH on the right side only and H on the left side. And in the last carbon, we have CH2OH. So here we have to keep in mind the relative positions of hydrogen and hydroxyl group. Okay, that means whether it is on the left side or the right side. Now when it reacts with hydroxylamine, that means NH2OH, then what happens? The oxygen of this aldehyde and H2 of hydroxylamine reacts to form water. Okay, so there is removal of water molecule, and at this position the bond that forms is CH double bond NOH. Okay, and rest of the things will remain same. That means 5 more carbons, 1, 2, 3, 4, 5, and then at the first carbon OH on the right side, at the second carbon OH on the left side, at the third and fourth OH on the right side, and in the last carbon CH2OH. Okay, and at that rest of the positions we have hydrogen. So let's see, in the first option we have OH on the right side, this is correct, but in the third and the second and third we have hydrogen on the right hand side, but here OH should be on the right side, so this is incorrect. Then in the second option we have hydrogen on the right hand side. Okay, so this is incorrect. Then in the third one we have hydrogen on the right side, so this is also incorrect. And in the last option we have OH on the right side, then hydrogen, then OH and OH on the right side. Okay, so this is the correct structure, so option D will be the correct answer. Okay. Question number 79 is again from the chapter Biomolecules, and the question is, which of the following hormones is produced under the condition of stress which stimulates glycogenolysis in the liver of human being? So which hormone is produced under the condition of stress? Options are thyroxine, insulin, adrenaline and estradiol. So the correct option is option C, that is adrenaline. Okay, it is produced by the adrenal gland. Adrenal gland. So this is a factual question. You should remember this fact. So option C will be your correct answer. Question number 80 is from the chapter Polymers, and the question is, which one of the following is an example of thermosetting polymer? So let's see. The structure given in the first option is the structure of neoprene. Neoprene, which is an elastomer. Okay, it is an elastomer, not a thermosetting polymer. Then the second structure is of polyvinyl chloride, PVC, which is a thermoplastic polymer. Thermoplastic polymer. So you should know the structures of different types of polymers. Okay. The third option is nylon 6,6. Nylon 6,6, which is an example of fiber. And the last structure is of novolac. Novolac, which is an example of thermosetting polymer. Thermosetting polymer. So according to the question, the correct answer will be option number D. Question number 81 is again from the chapter Polymers, and the question is, which of the following organic compounds polymerizes to form polyester dacron? So the polyester dacron is formed by the polymerization of terephthalic acid and ethylene glycol. Okay, so N molecules of terephthalic acid. This is the benzene ring of terephthalic acid. One carboxyl group here and another carboxyl group at this position. Plus N molecules of ethylene glycol, CH2OH and CH2OH. So this reaction will take place at a temperature of about 420 to 460 Kelvin, and with the help of zinc acetate plus antimony oxide Sb2O3. Okay, so as a result, the product that will be formed is Dacron with the structure OCH2, CH2O, then C double bond O, then benzene ring, C double bond O, and this will continue. Okay, so this is the polymer Dacron. So the correct option will be option number C, terephthalic acid and ethylene glycol. Question number 82 is from the chapter Environmental Chemistry, and the question is, which one of the following is not a common component of photochemical smog? Options are ozone, acrolein, peroxyacetyl nitrate and chlorofluorocarbons. So this is a factual question again. We know that ozone, acrolein and peroxyacetyl nitrate are all components of photochemical smog. But chlorofluorocarbons is not a component of photochemical smog. So option D will be the correct answer. Question number 83 is from the chapter Organic Chemistry, and the question is, in the Jadal's method for estimation of nitrogen present in soil sample, ammonia evolved from 0.75 grams of sample neutralized 10 ml of 1 molar H2SO4. The percentage of nitrogen in the soil is, okay. So what is given? Mass of the sample is given here. Mass of the sample is given as 0.75 grams. Then volume of sulfuric acid is given as 10 ml, whereas the molarity of sulfuric acid is given as 1 molar. Okay. Now we have to find the percentage of nitrogen. So that will be equal to 1.4 into normality of sulfuric acid into volume of sulfuric acid upon mass of the sample. Okay, this is the formula to find the percentage of nitrogen. So here, what is the value of normality of sulfuric acid? That we don't know, that we have to find out. So for that, let's write down the reaction. We have ammonia. It reacts with sulfuric acid. So it forms NH4 twice SO4. Okay, this is the reaction for the given condition. So here you can see that from sulfuric acid, 2 hydrogen atoms have been replaced by NH4 groups, right? That means the number of replaceable hydrogen is 2. Okay, number of replaceable hydrogen is 2. That means N factor is equal to 2 here. So from this we can find out the value of normality. Normality is equal to molarity into N factor. So molarity is given in the question, 1 molar, and N factor is 2. That means the number of replaceable hydrogen is 2. So that will be equal to 2. Okay, this is the normality. The value of normality is 2. So let's put the values in the given formula. Percentage of nitrogen will be equal to 1.4 into normality, that is 2, into volume of sulfuric acid, that is 10 ml, upon mass of the sample, that is 0.75 grams, right? So on solving this, we'll get the value 37.33%. Now if you check the options, the first option is the correct answer. Okay, option number A. Question number 84 is from the chapter Haloalkanes and Haloarenes, and the question is, what product are formed when the following compound is treated with bromine in the presence of FeBr3? So we have two methyl groups attached to the benzene ring, and we know that methyl group is ortho-para directing. Okay, methyl group is ortho-para directing. That means it will direct the incoming group at ortho and para positions. Okay, let's say this is methyl number 1 and this is methyl number 2. So with respect to any one of the methyl groups, the incoming group, that means bromine, should be attached either at ortho position or at para position. Actually, if two compounds are obtained, then in one it will be attached at ortho position and the other it will be at para position. Okay, so let's check. In the first option, we have bromine attached to the ortho position. Okay, this is at the ortho position with respect to methyl number 1. Okay, and in the second compound it is at the para position with respect to methyl number 1. So yes, here we are getting ortho and para products both, but in the first product bromine is present between two methyl groups, so due to this there will be steric hindrance. Steric hindrance, and steric hindrance will cause the instability. Okay, instability. So this compound will be unstable, so this is not the correct option. Now let's move to the second option. Here if we talk with respect to methyl group 1, this one. So both the compounds bromine are attached at the ortho position with respect to methyl number 1. But with respect to methyl number 2, in the first compound it is at para position, and in the second compound it is at ortho position. But again, in the second compound bromine is present between two methyl groups, so this will be unstable. Okay, so this is also incorrect. Now let's come to the third option. Here with respect to the methyl group 1, the first compound has bromine at ortho position and the second compound has bromine at the para position, and there is no steric hindrance in this case. No steric hindrance, plus we are getting ortho as well as para products. So this should be the correct answer. In the last option, we have at para position with respect to the first one, and in the second one, this is not at para position, this is at meta position, so this is incorrect. So the only correct option is option number C. Okay. Question number 85 is again from the chapter haloalkanes and haloarenes, and the question is, which of the following compounds will undergo racemization when solution of KOH hydrolyzes? So the simple fact that we should know here is that for racemization at least one chiral carbon should be present in the compound. Okay, so a chiral carbon is required. And what is a chiral carbon? The carbon with four different groups bonded to it. Okay, carbon with four different groups. So let's check. In the first one, we don't have any chiral carbon. No chiral carbon. Because with this carbon, two hydrogen are attached, but in chiral carbon, no two groups can be same. So this is not correct. Then in the second one also, no chiral carbon is present. In the third one also, if we talk about this carbon, so two methyl groups are attached to it. So these are same. Again, to this carbon, two hydrogens are attached. So this is also not a chiral carbon. So no chiral carbon here also. And in the last one, we have a chiral carbon. Okay, this carbon is a chiral carbon because four different groups are bonded to it. One is methyl, then chloride, then ethyl, and then hydrogen. Okay, so since this is a chiral carbon, so this compound will undergo racemization. Okay, now let's check what are the options. 1 and 2, 2 and 4, 3 and 4, and last one is only 4. So yes, only 4 is the correct answer because none of the others are having a chiral carbon. So option D will be the correct answer. Question number 86 is from the chapter Alcohols, Phenols and Ethers, and the question is, among the following sets of reaction, which one produces anisole? So what is anisole? It is another name of methoxybenzene. Methoxybenzene. Let's see the structure of anisole. We have a benzene ring here, and then we have a methoxy group, that means OCH3. So for the formation of anisole, we need a phenol plus a compound containing methyl group. Okay, compound containing methyl group. So what will happen? Methyl group will get attached to the phenol. Okay, so in the first option we don't have a phenol, this is ethanal. Okay, and we need a phenol. In the second option we have a phenol, yes, and then we have methyl iodide as well. So from here methyl group can come and attach to the benzene ring. So yes, this can be possible. In the third one we have phenol, but we don't have anything containing methyl, and in the last one we don't have phenol. So the only correct option can be second one. Let's see the reaction. We have a phenol, this is benzene ring, then OH. This is phenol plus NaOH. So first what will happen? The reaction between these two will take place and we'll get a phenoxide ion. This is benzene ring. Here we get ONA, O minus Na plus. Okay, and then it will further react with methyl iodide. So this methyl group will replace sodium. So here we'll get OCH3. Okay, and sodium iodide will get removed from here. So this is your final product anisole. So which is the correct answer? Option number B is the correct answer. Question number 87 is from the chapter Alcohols, Phenols and Ethers, and the question is, which of the following will not be soluble in sodium hydrogen carbonate? Option A 2,4,6-trinitrophenol, option B benzoic acid, option C orthonitrophenol, and option D benzene sulfonic acid. So we know that when an acid reacts with sodium hydrogen carbonate, then what is formed? Sodium salt of acid is formed. Okay, sodium salt of the acid plus hydrogen carbonate H2CO3 is formed. Right, now this sodium salt is soluble. So this is the general reaction. Now what is the condition for this reaction? The condition for this reaction is that the strength of the acid should be more than the strength of hydrogen carbonate. Okay, so the given acid should be more acidic than hydrogen carbonate. Out of the given options here, there is one option orthonitrophenol which is less acidic than hydrogen carbonate. Okay, less acidic than hydrogen carbonate. Therefore, it will not be soluble in sodium hydrogen carbonate, whereas all the others are more acidic than hydrogen carbonate. So option C will be the correct answer. Question number 88 is from the chapter Aldehydes, Ketones and Carboxylic Acids. And the question is, which one is most reactive towards nucleophilic addition reaction? Okay, so here you can see we have carbonyl group, C double bond O in all the given options. Now here in this carbonyl group, oxygen will have partial negative charge, whereas carbon will have partial positive charge. Now a nucleophile will attack this electrophilic center, that means the carbon having partial positive charge. Now more the positive charge on carbon, more the positive charge on carbon, more is the reactivity towards nucleophilic reaction. Okay, nucleophilic reaction. And we know that when electron donating group is present, it will donate electron towards carbon, and therefore it will increase the negative charge. That means it will become less positive. Whereas if electron withdrawing group is present, then it will take away the negative charge. That means it will make the carbon more positive, right? More positive. That means which condition is favorable for nucleophilic reaction? This one, electron withdrawing group. Presence of electron withdrawing group is favorable for the nucleophilic reaction. Okay, so in the first option you can see we don't have any group, neither electron donating group nor electron withdrawing group, so it will have no effect. In the second one we have CH3 attached to the carbonyl group. That means this CH3 is electron donating group. We know that electron donating group. So it will make it less reactive towards the nucleophilic addition because it will make the carbon less positive. Okay, so it is not possible. Then in the third option again we have methyl group. So this is electron donating, so it will make the carbon less positive. Now let's come to the last option. Here we have nitro group, and we know that nitro group is electron withdrawing group. And we know that an electron withdrawing group favors the nucleophilic attack. So The correct answer will be option number D. Okay, this compound is most reactive towards nucleophilic addition reaction. Question number 89 is from the chapter Alcohols, Phenols and Ethers, and the question is identify Z in the sequence of reaction. So let's write down the reaction here. We have CH3, CH2, CH, double bond CH2. Now it reacts with HBr, hydrogen bromide, in the presence of hydrogen peroxide to give a product Y. So what is that product Y? See, since hydrogen peroxide is present, therefore this reaction will follow anti-Markovnikov's rule. What is anti-Markovnikov's rule? According to this rule, the negative part of the reagent, that is bromide ion in this case, will get attached to the less substituted doubly bonded carbon. Okay, less substituted doubly bonded carbon. So two carbons are doubly bonded here, these two. Now out of these two, which one is less substituted? The one having more number of hydrogen, that means the first carbon. So bromide ion will get attached to this carbon. Okay. As a result, the product Y that we will get is CH3, CH2, CH2 and CH2Br. This is the product Y. Now this product Y is reacting with sodium ethoxide C2H5ONa to give the product Z. So we have to identify this product Z. So this reaction is Williamson synthesis. Williamson synthesis. And it leads to the formation of an ether. Okay. So this ethyl group C2H5 will get added here. So the product Z is CH3, CH2, CH2, CH2O, C2H5. Okay. So how many carbons are there? Total 1, 2, 3, 4, 5 carbons. One is CH3. Then we have 3 CH2. Okay. CH2 3 times. Then O. Then C2H5. So let's check. In the first option we have CH3. Then 3 times CH2. Then O. Then CH2, CH3. So yes, this is the correct product. Okay. In the next option we have 2 times CH3, so this is incorrect. Then we have 4 times CH2 in the third option, so this is also incorrect. And last one is also incorrect. So the only correct option is option number A. And now the last question is from the chapter Hydrocarbons, and the question is which of the following organic compounds has same hybridization as its combustion product carbon dioxide? So what is the structure of carbon dioxide? Carbon oxygen double bond, and this side also carbon oxygen double bond. And what is the hybridization of this carbon? sp hybridization. Okay, that means the organic compound should also have sp hybridized carbon. Okay, and we know that which type of hydrocarbon has sp hybridized carbon? Alkynes. That means ethine. Option B will be the correct answer. It will also have sp hybridized carbon. Okay. So here we complete all the chemistry questions from NEET 2014 paper. We'll be back with another session soon. Till then, keep learning, keep scoring high. For a better understanding, I would suggest you to practice same questions from our website www.examsnet.com, and for more information, please download our app from the link given in the description. Thank you so much.